What if everything you've ever learned about the cosmos, the stars, the galaxies, even the nature of reality itself wasn't just incomplete, but intentionally misleading? Picture this for a moment, a universe brimming with unexplained phenomena, cosmic coincidences too perfect to be random, and scientific discoveries that somehow never make it into your textbooks. We look up at the night sky with awe, trusting that science has given us the full story. But what if some truths are considered too disruptive, too unbelievable, or too dangerous to share openly? From whispered rumors in academic circles to declassified documents that hint at far more than they reveal, there's a growing sense that we've been kept in the dark about the true nature of existence. It's not about conspiracy for the sake of drama. It's about asking why certain ideas are suppressed, who benefits from our ignorance, and what we're truly capable of understanding when we dare to look deeper. Today, we're pulling back the curtain on 30 cosmic truths that have been hidden in plain sight, truths that challenge the very foundations of what we think we know. These aren't just wild speculations, they're grounded in anomalies that science can't fully explain, in patterns that defy probability, and in evidence that points toward a reality far stranger and more magnificent than we've been led to believe. Imagine uncovering secrets about black holes that aren't voids but gateways, about ancient civilizations that might have possessed cosmic knowledge lost to time, or about dimensions that exist just beyond our perception. This isn't science fiction, it's a reality that has been carefully filtered, sanitized, and packaged into a narrative that keeps us comfortable but ultimately in the dark. The journey we're about to take together will forever change how you see the universe and your place within it. So settle in and open your mind, because what you're about to discover goes beyond ordinary astronomy or physics. This is an exploration of the profound, the mysterious, and the deliberately obscured. Each of these 30 revelations will piece together a bigger picture, one that hints at a cosmos alive with possibility, intelligence, and layers of truth waiting for those brave enough to seek them. You'll walk away not just with answers, but with better questions and a renewed sense of wonder about the universe we call home. The cosmos is speaking to us in ways we're only beginning to understand, and it's time we listen. Let's begin with one of the most profound and unsettling ideas that has drifted from the fringes of philosophy into serious scientific debate: the possibility that our universe is not base reality, but an incredibly advanced simulation. Think about the world around you, the feel of your chair, the sound of my voice, the vastness of the night sky. It all feels undeniably real. But what if these sensations are merely data points rendered by a cosmos-sized computer? This isn't just a plot from a science fiction movie. It's a hypothesis that is increasingly difficult to dismiss when we examine the very fabric of reality through the lens of modern physics. Quantum mechanics, the rules that govern the subatomic world, provide some of the most compelling clues. Particles can be in two places at once. They instantaneously influence each other across vast distances through quantum entanglement in a way that seems to break the universal speed limit of light, and they don't assume a definite state until they are observed. It's almost as if the universe is conserving processing power, only rendering the fine details of reality when someone is looking. This observer effect is less a feature of a stubbornly objective universe and more like a clever programming trick to optimize a system's resources. Then there are the cosmic constants, the fundamental forces and numbers that make our universe possible. The force of gravity, the strength of the electromagnetic force, the mass of a proton. These values are so exquisitely fine-tuned that even the slightest variation would make life, stars, and planets impossible. It's like dialing in a combination lock with a near-infinite number of dials and getting it right on the first try. The odds against this happening by random chance are astronomically low, suggesting something or someone set these parameters intentionally. In a simulation, these aren't mysterious accidents. They are the initial settings typed into the cosmic command line. philosopher Nick Bostrom formalized this argument in 2003, presenting a sobering trilemma. He argued that at least one of three propositions must be true. First, that virtually all civilizations at our level of technological development go extinct before achieving advanced simulation capabilities. Second, that advanced civilizations universally lose interest in creating such simulations. Or third, we are almost certainly living in a simulation created by a more advanced civilization. Given the trajectory of our own technology, where we are already creating rudimentary virtual worlds, the first two options feel increasingly like wishful thinking. The most logical conclusion is the third. This idea is no longer confined to philosophy departments. Tech visionaries and respected physicists have publicly entertained the possibility, not as a fun thought experiment, but as a legitimate scientific hypothesis. They argue that if any civilization ever reaches a level where it can simulate conscious beings, the number of simulated minds would eventually vastly outnumber the biological ones. Statistically, the chances that you are one of the original organic beings, rather than one of the countless simulated ones, are vanishingly small. You are almost certainly living in a reality constructed by beings whose technology is indistinguishable from what we would call magic. This isn't a cause for despair, but a breathtaking invitation to reconsider everything we assume about existence, consciousness, and our place in the cosmos. Building on the idea that reality might be a rendered experience, we encounter an even more startling proposition. What if the very thing accelerating the expansion of the universe is not an unknown force, but a familiar one? We call it dark energy, a placeholder name for the mysterious pressure ripping the cosmos apart at an ever-increasing rate. But what if this enigmatic energy is not some distant, impersonal phenomenon? What if it is intrinsically connected to the one thing science has struggled to explain within a purely material framework, human consciousness itself? This concept bridges the gap between the vast external cosmos and our intimate internal world of awareness. In laboratory settings, the act of observation has been proven to alter the behavior of quantum particles, a phenomenon that has baffled physicists for decades. The prevailing Copenhagen interpretation suggests a particle's wave function collapses into a definite state only when measured, but measured by what? The implication is that consciousness itself is the catalyst, the fundamental ingredient that actualizes potential into reality. Now, extend that principle from a laboratory experiment to the entire universe. Could the cumulative effect of observation, of conscious awareness throughout the cosmos, be exerting a literal force on the fabric of space-time? It's a staggering thought that our collective attention might not just be witnessing the universe, but actively participating in its creation and expansion. Mainstream scientific institutions often sideline this radical connection, and the reason is deeply philosophical. The current paradigm is firmly rooted in materialism, the belief that everything, including thoughts, emotions, and consciousness, can be reduced to physical matter and mechanical processes. To suggest that consciousness is a primary, causal force that interacts with the cosmos on a fundamental level is to challenge the very foundation of modern science. It opens the door to concepts that sound more like mysticism than physics, making many academics understandably wary. Research proposals exploring this link often struggle for funding and face significant peer review skepticism, not necessarily because the ideas lack merit, but because they threaten to dismantle a worldview that has been built over centuries. Yet the evidence, while controversial, is compelling. Studies on the Global Consciousness Project, which uses a network of random number generators scattered around the world, have reported statistically significant deviations from randomness during major, globally shared events of high focus and emotion, like the turn of the new millennium or tragic world events. It's as if a unified field of human consciousness can briefly impose order on chaos. Furthermore, the mathematical properties of dark energy, its uniform distribution and constant strength, mirror what we might expect from a fundamental field of awareness that is everywhere at once, not diminishing with distance but inherent to the vacuum of space itself. This isn't to say scientists are part of a malicious cover-up. Rather, they are guardians of a paradigm, a necessary role to prevent pseudoscience from running rampant. But true scientific progress has always occurred when a paradigm cracks under the weight of too many anomalies it can no longer explain. The refusal to seriously investigate the consciousness-dark energy link is a modern example of this tension. It protects the established model but may also be holding us back from a monumental leap in understanding. Accepting this connection would mean redefining our place in the universe not as accidental passengers on a rock flying through space, but as active participants whose very awareness helps to weave the cosmic tapestry. We are not just living in the universe is, in a very real sense, living through us. Now consider the stories etched into the very oldest records of human history. Tales not of primitive struggle but of gods and heroes navigating the heavens in magnificent flying machines. These aren't isolated myths, they are startlingly consistent accounts from cultures separated by oceans and millennia, describing technology that we are only now beginning to reinvent. The ancient Indian Vedas, for instance, contain incredibly detailed descriptions of Vamana's aerial chariots powered by mercury vortex engines and capable of incredible speeds and maneuvers. The text known as the Samaranga Sutradhara spends entire chapters not on mythology, but on the operational manuals for these machines, how they were constructed, how their engines were started, and even how they could be rendered invisible in battle. This isn't the vague language of allegory, it's the precise terminology of aerospace engineering, appearing in texts thousands of years old, but the evidence isn't confined to texts alone. Scattered across the globe are physical artifacts that defy the conventional timeline of human technological progress. In the ruins of a Parthian village near Baghdad, a simple clay jar was unearthed in the 1930s. Inside was a copper cylinder housing an iron rod sealed with an asphalt plug. When filled with an acidic substance like vinegar, this 2,000-year-old object produces a measurable electric current. Dubbed the Baghdad Battery, its purpose remains a subject of fierce debate. Was it used for electroplating jewelry, for religious experiences, or perhaps for something we haven't even considered? Its existence alone proves that the concept of generating electricity was understood long before Galvani or Volta. Then there is the Antikythera mechanism, recovered from a shipwreck off the coast of Greece. This complex assembly of bronze gears, dating back to the 2nd century BCE, is often called the world's first analog computer. Its intricate dials and mechanisms could accurately predict astronomical positions, eclipses, and even the cycles of the Olympic Games. The level of miniaturization and precision engineering it displays would not be seen again until the development of mechanical clocks in Europe over 1,000 years later. It stands as a silent, rusted rebuke to the idea of linear, steady progress, suggesting instead that advanced knowledge can be lost, buried by time and catastrophe. So why is this not common knowledge? Why are these findings often relegated to the fringes of history and archaeology? The answer lies in a concept known as paradigm protection. The established timeline of human history, a steady climb from primitive tools to modern technology, is the foundational framework upon which countless academic careers, textbooks, and museum exhibits are built. To seriously entertain that advanced technology existed in antiquity is to threaten that entire structure. It forces a humbling and inconvenient rewrite of everything we think we know about our own past. For an academic who has spent a lifetime building expertise within a specific model, evidence that undermines that model is not just a new data point, it is a professional existential threat. Consequently, artifacts that don't fit the narrative are often dismissed out of hand. The Baghdad Battery is explained away as a mere storage jar for sacred scrolls, despite the clear evidence of electrochemical corrosion on its inner rod. Descriptions of Vimanas are labeled as poetic metaphors or later additions, ignoring their deep integration into the original texts. The standard retort is that without a smoking gun, like a fully intact Vimana, such claims remain speculative. But this ignores a fundamental truth of archaeology. We are only ever uncovering a tiny, fragmented fraction of the past. Advanced technology, especially that which might utilize organic or perishable materials, would leave little trace after thousands of years. Our entire understanding of history is built on the lucky survival of stone, pottery, and some metals, while the vast majority of human innovation, potentially including its most brilliant achievements, has turned to dust. This isn't about claiming aliens gave us technology. It's about accepting the possibility that human ingenuity has peaked and collapsed before, that civilizations have risen to dazzling heights only to be wiped clean by planetary cataclysms, leaving behind only scattered clues and legends that we dismiss as myths. By ignoring this evidence, the gatekeepers of history aren't just protecting a paradigm, they are limiting our understanding of human potential. They are enforcing a narrative of recent superiority, subtly suggesting that we alone in this sliver of time have achieved greatness. In doing so, they rob us of a deeper connection to our ancestors and a more profound, and perhaps warning, perspective on the cyclical nature of civilization itself. Of course, the most destructive objects in the universe might also be its greatest architects. We've long been taught to fear black holes, these cosmic monsters whose gravity is so intense that not even light can escape their grasp. They are the ultimate endpoints, the great devourers of stars. But what if that terrifying image is only half the story? A growing chorus of theoretical physicists proposes a radically different function for these enigmatic objects. They might not be final graves, but rather tunnels, dynamic portals, or wormholes connecting our region of space-time to another universe, another dimension, or a distant part of our own. This idea transforms them from monstrous voids into the most profound transportation system imaginable, woven into the fabric of the cosmos. The mathematics behind Einstein's theory of general relativity actually allows for such a possibility. The equations describe a phenomenon called an Einstein-Rosen bridge, a theoretical shortcut through the contorted fabric of spacetime. Imagine the universe as a vast piece of paper. To get from one end to the other, you'd have to travel the entire length. But if you could fold that paper, bringing two distant points together, a black hole could be the puncture connecting them, a tunnel through a higher dimension we cannot perceive. The matter and energy that falls in doesn't vanish. It could be being transmitted elsewhere, perhaps birthing a new universe or fueling another region of existence. This isn't wild speculation. It's a legitimate, albeit extreme, solution to the equations that govern gravity itself. Even the late, great Stephen Hawking, a titan of cosmology, subtly nudged this idea into the mainstream. He famously worked on the black hole information paradox, wrestling with what happens to the information about an object once it crosses the event horizon. According to quantum mechanics, information cannot be destroyed, yet black holes seem to erase it completely. Hawking's later work suggested that this information might not be lost at all. Instead, it could be encoded on the event horizon itself, the point of no return, or perhaps even transmitted to another realm. While he never outright declared black holes were wormholes, his theories opened a door to that very possibility, hinting that these objects preserve and transfer information in ways we are only beginning to decipher. So why is this transformative concept relegated to the fringes of scientific discourse? Why isn't every astronomy textbook shouting this from the pages? The resistance is multifaceted. First, there's the sheer mind-bending weirdness of it. Accepting that black holes are portals requires a fundamental shift in our understanding of physics and reality that many are not prepared to make. It ventures into territory that feels closer to science fiction than hard science, making it a career risk for any researcher who might champion it too vigorously. The mainstream institutions, which prioritize incremental progress and testable hypotheses, naturally shy away from ideas that are, for now, nearly impossible to observe or prove with our current technology. But there may be a deeper, more philosophical reason for the dismissal. The implications of black holes as portals are existentially disruptive. It suggests that our universe is not a closed, isolated system, but is potentially connected to a multiverse, an infinite tapestry of realities. This connection would mean we are not alone in a cosmic sense far grander than just extraterrestrial life. Our entire reality might be just one page in an infinite book. This idea can be deeply unsettling, challenging not only scientific orthodoxy, but also humanity's cherished sense of uniqueness and centrality. For some in positions of academic authority, it is far easier to label such ideas as pseudoscience than to confront the profound upheaval they would cause to our entire cosmological worldview. The potential for public confusion or even panic over such a paradigm shift, however unlikely, is a risk many established institutions would rather not take, choosing instead to maintain a more comfortable, if incomplete, narrative about the nature of these cosmic giants. Yet for all its familiarity, our moon is the solar system's greatest anomaly, an object so bizarre in its composition and behavior that the very idea it formed naturally alongside Earth stretches credibility to its breaking point. Let's start with its density. The moon's overall density is significantly lower than Earth's, but this isn't the strangest part. When NASA placed seismometers on the lunar surface during the Apollo missions, they made a shocking discovery. When the lunar modules were deliberately crashed back onto the moon or when meteorites struck, the entire moon reacted like a giant, ringing bell. Seismic reverberations lasted for an astonishingly long time, sometimes over an hour. On Earth, such vibrations would fade in minutes. This phenomenon led Dr. Gordon MacDonald, a NASA scientist, to openly state in the 1960s that the data suggests the moon is more likely hollow than homogeneous. A natural rocky body simply cannot behave that way. Then there's the impossible precision of its orbit. It's common knowledge that the moon perfectly eclipses the sun, its disk appearing to be the exact same size in our sky. This is because of a 1 in a billion coincidence. The sun is approximately 400 times larger than the moon, but it's also 400 times farther away. The odds of this perfect alignment occurring by chance are astronomically low, but the strangeness doesn't end there. The moon's rotation is perfectly tidally locked with Earth, meaning we only ever see one side of it. This is not uncommon for moons, but the mechanics of how our large moon achieved this lock without a wildly erratic past orbit continue to confound astrophysicists. Its orbit is also nearly a perfect circle, unlike the elliptical paths of almost every other moon in the solar system. It behaves less like a captured asteroid and more like a perfectly placed, finely tuned piece of celestial clockwork. This is where the theory, first seriously proposed by Russian scientists Mikhail Vasin and Alexander Asecherbakov in a 1970 article titled, "Is the Moon the Creation of Alien Intelligence?" enters the picture. They argued that the moon's many contradictions could be explained if it were not a natural satellite, but an ancient planet-sized artificial structure, a kind of ark or spaceship that was deliberately placed in orbit around Earth. Its rocky crust, they suggested, could be a several-mile, thick layer of debris and processed minerals designed to shield an incredibly strong inner hull from micrometeorites and the harshness of space. The hollow interior, the strangely concentrated mass contains areas of denser mass that cause gravitational anomalies under its seas, and its unusual metallic composition all fit within this framework. It's a construct, a relic of a technology so advanced it manipulates the very forces of gravity itself. Apollo mission data only adds more puzzling pieces to this mosaic. Astronauts reported encountering clouds of strange, sparkling glassy particles and experiencing unexplained artificial lights and transient phenomena on the surface. More tellingly, when the Apollo 12 crew jettisoned their ascent stage, sending it crashing back to the moon, the impact registered as a seismic event that made the moon ring like a gong for nearly 40 minutes. One scientist from the Jet Propulsion Laboratory was famously quoted as saying, "The moon not only rang like a bell, but the whole moon wobbled in such a precise way that it was almost as though it had gigantic hydraulic damper struts inside it." So why is this not a mainstream topic of scientific inquiry? Why is the artificial moon hypothesis relegated to the fringes? The answer is the profound societal implications. Admitting that a constructed object of unimaginable age and technology hangs in our sky would trigger a paradigm shift that would make the Copernican revolution look minor. It would force us to completely rewrite human history, astronomy, and even our understanding of our own origins. It would prove that we are not the pinnacle of intelligence in the universe, and that forces beyond our comprehension have been, and perhaps still are, present in our most immediate cosmic neighborhood. Such a revelation could shatter religious doctrines, collapse economic systems built on a certain view of progress, and potentially lead to widespread existential panic. The keepers of the status quo, from government agencies to academic institutions, have a vested interest in maintaining social stability. Allowing such an earth-shattering truth to enter public consciousness is seen as an unacceptably dangerous risk. It's not a conspiracy of evil, but one of control, a paternalistic decision that humanity is not yet psychologically or socially ready to handle the truth about our closest celestial companion. The moon's secret is kept not because it is unknowable, but because knowing it changes everything. But if the nature of the moon challenges our place in space, the very fabric of time itself presents an even more fundamental illusion. We experience our lives as a steady, unbroken march from a fixed past through a fleeting present and into an unknown future. This feels like the most basic, undeniable truth of existence. Yet, the twin pillars of modern physics, Einstein's theory of relativity and quantum mechanics, shatter this comforting linearity, revealing time not as a universal river flowing in one direction, but as a complex, malleable, and perhaps entirely subjective construct. Einstein's work was the first great crack in the foundation. His theory of special relativity showed that time is not absolute, it dilates. A clock in motion ticks slower than a clock at rest. This isn't a theoretical abstraction, it's a measurable, everyday reality for GPS satellites, whose onboard clocks must be constantly corrected for the effects of both their speed and Earth's gravity. Two perfectly synchronized clocks, if one is sent on a high-speed journey and then returned, will show different elapsed times. The traveler would have aged less than the person who stayed behind. This means there is no single now that applies to the entire universe. Your present moment is relative, entirely dependent on your state of motion and your position within a gravitational field. The past, present, and future of distant events are not fixed facts but depend on the observer's frame of reference. In a very real sense, all of time, past and future, might exist simultaneously in a vast, four-dimensional block universe, and our conscious experience of moving through it is just that, a unique experience, not a fundamental law. While relativity warps time on a large scale, quantum mechanics attacks its linearity at the smallest scales with even more bizarre implications. Consider the infamous double-slit experiment. When you fire particles like electrons at a barrier with two slits, they behave like waves and create an interference pattern on the screen behind it, as if each electron is passing through both slits at once. But if you place a detector at one slit to observe which path the electron takes, the wave-like behavior collapses. The electron acts like a single particle and the interference pattern vanishes. The act of observation in the present definitively alters the behavior of the particle in the past. This alone suggests a profound connection across what we perceive as time. This gets even stranger with a variation called the delayed choice quantum eraser experiment. In this setup, scientists can choose to measure which path a particle took after it has already passed through the slits but before it hits the final screen. Astonishingly, the decision made in the future seems to retroactively determine how the particle behaved in the past. If the path information is erased after the fact, the interference pattern magically reappears. The particle's decision to act like a wave or a particle is influenced by an observation that hasn't technically happened yet from its perspective. This isn't just a quirk of tiny particles. It suggests that at the most fundamental level of reality, the future can and does influence the past. Cause and effect, the bedrock of our logical understanding of the world, become tangled and lose their meaning. So why is this mind-bending truth about time not a part of our common knowledge? Why do we still structure our entire society, our laws, our histories, our very sense of self around a linear progression that physics tells us is an illusion? The reason is that this truth is actively hidden, not in secret files, but by the very architecture of our consciousness. Our brains have evolved as survival engines, and to navigate a world of cause and effect, they had to create a simplified, linear narrative of events. This perception is a user interface, a dashboard that hides the overwhelming, simultaneous complexity of the block universe from our awareness. To experience reality as it truly is, with all moments equally present, would be paralyzing. We wouldn't be able to function, make decisions, or learn from our mistakes. Our linear perception of time is a necessary filter, a cognitive tool that allows us to operate within the universe without being overwhelmed by its true nature. Accepting that time is an illusion would force a radical and deeply uncomfortable shift in our understanding of free will, responsibility, and destiny. If the future is already out there, as real as the past, then are our choices truly our own? This idea is so existentially disruptive that even many physicists shy away from its full implications, offering various interpretations of quantum mechanics that attempt to preserve a more classical flow of time. The mainstream scientific presentation often glosses over these radical experiments, framing them as microscopic curiosities with no bearing on our macroscopic world. But this is a convenient dismissal. If the foundation is not linear, how can the house built upon it be? The truth is being hidden to protect our perception of a stable, predictable reality, a reality that is necessary for us to function as individuals and as a society, even if it is ultimately a magnificent, beautiful illusion. Consider the very particles that streak through the void, unseen and unfelt, yet carrying the power to rewrite the blueprint of life itself. We are constantly bathed in a shower of high-energy cosmic rays, subatomic bullets fired from the depths of supernova and distant quasars. While our planet's magnetic field and atmosphere act as a protective shield, they are not a perfect barrier. For astronauts in orbit or on the surface of the Moon, this protection is vastly diminished, and the effects on their biology are both immediate and deeply concerning. These rays don't just pass through tissue, they can slice directly through DNA, causing double-strand breaks and complex damage that our cellular repair mechanisms struggle to fix. The result isn't just a heightened risk of cancer, it's the potential for immediate and unpredictable genetic mutation. The official line from space agencies has always focused on risk mitigation, better shielding, shorter missions, pharmaceutical countermeasures. But this pragmatic approach may be obscuring a far more profound and unsettling truth. What if this constant genetic bombardment isn't merely a hazard to be managed, but a fundamental driver of biological change? The fossil record shows periods of rapid speciation and evolutionary leaps that classic models of gradual mutation and natural selection struggle to explain. Could pulses of intense cosmic radiation from a nearby supernova or a shift in Earth's protective magnetosphere have acted as a cosmic mutagen, catalyzing sudden and dramatic transformations in life on Earth? This theory, while controversial, offers a compelling explanation for some of biology's greatest mysteries, suggesting that our own evolution may have been directed in part by the violent events of the distant cosmos. This leads to an even more radical notion that our journey into space might be doing more than just exposing us to this radiation. It might be actively triggering a new wave of human evolution. Astronauts returning from long-duration missions on the International Space Station show measurable changes at a cellular level, including telomere lengthening and alterations in gene expression. While many of these changes revert after returning to Earth, some effects persist. The constant barrage of high-energy particles could be acting as a forced evolutionary pressure, scrambling our genetic code in ways we are only beginning to comprehend. The potential outcomes are vast and unknown, perhaps enhanced cognitive abilities, new physiological adaptations for low-gravity environments, or, unfortunately, degenerative conditions we cannot yet predict. Given these staggering implications, the question becomes why this isn't a central topic of public scientific discourse. The reason is likely not malice, but a calculated decision to manage perception and fear. The entire enterprise of human spaceflight, particularly ambitious projects to establish a permanent presence on the Moon or Mars, is built upon a foundation of public and political support. That support is contingent on the perception of manageable risk. Openly discussing the possibility that space travel could fundamentally and unpredictably alter human DNA at a generational level would introduce a profound ethical and existential dilemma. It could spark panic about creating a new, divergent branch of humanity, or raise fears about astronauts returning as genetically altered individuals. Such a conversation would immediately jeopardize funding and public enthusiasm for space exploration. Therefore, the research that does exist is often framed in the driest, most clinical terms possible, focusing on cancer risks and radiation dosage limits while deliberately avoiding the larger philosophical questions. The more speculative and revolutionary ideas are kept within closed academic circles, their discussion limited to obscure journals and conferences. This isn't a conspiracy to hide the truth, but a form of paternalistic gatekeeping, a decision by those in authority that the public cannot be trusted with the full, terrifying picture of our cosmic future. They offer us the simplified version, the story of exploration and bravery, while quietly wrestling in private with the possibility that leaving Earth might mean leaving our very humanity behind. Yet for all its life-giving power, our sun may be far more than a simple nuclear furnace. It could be the most active and overlooked portal in our solar system. Ancient cultures across the globe, from the Egyptians to the Aztecs, didn't simply worship the sun as a god, they described it as a doorway, a point of connection to other realms and celestial beings. These myths, long dismissed as primitive symbolism, take on a startling new significance when examined through the lens of modern plasma physics and the inexplicable anomalies captured by our most advanced solar observatories. Plasma, the fourth state of matter that constitutes over 99% of the visible universe, behaves in ways that can seem almost intelligent. It forms twisting, filamentary structures and double layers that can accelerate particles to near light speeds. Nobel laureate Hans Alfvén, the father of plasma cosmology, theorized that under the right conditions, plasma could form scalable, galaxy-spanning circuits. Within this framework, a star like our Sun isn't an isolated object but a concentrated node in a vast cosmic network, a focal point for immense electrical energies flowing through space. This transforms the Sun from a passive ball of gas into an active, dynamic gateway, a transformer or a lens for energies that could facilitate travel or communication across interstellar distances. This theoretical possibility moved from speculation into the realm of tangible evidence with the launch of solar observatories like NAS, a Solar and Heliospheric Observatory, or SOHO, and the Solar Dynamics Observatory. These spacecraft have sent back millions of images of the Sun's corona, and within this torrent of data, amateur and professional researchers alike have identified countless objects that defy conventional explanation. They are not asteroids or comets. The most famous of these, dubbed the Solar Watcher or Giant UFO, appeared in SOHO imagery in the late 1990s. It was a structured, cylindrical object seemingly larger than Earth, suspended near the solar surface and withstanding temperatures that should vaporize any known material. Most startlingly, it appeared to be connected to the sun by a faint, energy-like filament, as if drawing power or transmitting it. The official response to these anomalies has consistently been to label them as compression artifacts, cosmic rays hitting the sensor, or ice particles drifting close to the camera. Yet for many of these events, that explanation falls painfully short. The objects often move with clear purpose against the solar wind, exhibit symmetrical, manufactured shapes, and appear in multiple frames and across different wavelengths of light. Even more telling is what happens to the data. Time and again, when such an anomalous object is spotted in the live feed from SOHO, the public data stream is abruptly interrupted, goes offline for maintenance, or returns with the specific frames containing the object mysteriously missing or corrupted. This pattern of censorship is too consistent to be coincidental, suggesting a deliberate effort to control the narrative and prevent these images from reaching a wide audience. The reason for this suppression is twofold. Firstly, acknowledging that intelligently controlled objects of immense size are operating near the sun would shatter our understanding of physics and technology. It implies the existence of a civilization with mastery over energy and materials that makes our own look primitive. Secondly, and more profoundly, it fundamentally alters the sun's role in our lives. It is no longer just a mindless force of nature we orbit. It becomes a central terminal in a cosmic highway, a place of immense activity and importance that we are only barely perceiving. This revelation would force a complete reevaluation of humanity's place in the cosmos, suggesting we are not the isolated pinnacle of intelligence, but perhaps a young species living in the backyard of a vastly older and more advanced interstellar community. The truth is hidden not because it is unknowable, but because knowing it would demand a humility and a paradigm shift that the current structures of power and scientific authority are not yet willing to embrace. Yet the most profound evidence for parallel universes may come from the quantum world itself, specifically a baffling phenomenon known as quantum superposition. This is the bizarre principle that a particle like an electron can exist in multiple states or locations at once, only settling into a single definite state when it is observed. The classic double-slit experiment demonstrates this perfectly. When you don't measure which slit a particle goes through, it behaves as if it passed through both simultaneously, creating an interference pattern. The moment you install a detector to observe its path, this wave-like behavior collapses and it acts like a single particle. The very act of looking seems to force the particle to choose just one reality. But what if it isn't choosing? What if every single possible outcome actually occurs, but in a separate, newly branched universe? This is the core of the many worlds interpretation, first proposed by physicist Hugh Everett in 1957. He argued that there is no collapse of the wave function. Instead, at every moment where a quantum event has multiple possible outcomes, the entire universe splits. In one branch, you see the electron go through the left slit. In another, absolutely identical branch, you see it go through the right slit. Both happen. Both are real. Every decision you've ever made, every random quantum event that ever occurred, spawned new universes. There's a world where you took that different job, a world where the dinosaurs weren't wiped out, and an infinite number of worlds where every conceivable variation of reality plays out. This interpretation isn't just philosophical speculation. It's a mathematically consistent way to explain the oddities of quantum mechanics without the need for a mysterious collapse triggered by consciousness. So if the math checks out and the theory is so elegant, why is this mind-bending concept not taught as fact in every physics classroom? The first reason is a fierce, almost territorial protection of the foundation of physics. The many worlds interpretation removes the observer from a special role, making the universe entirely objective and deterministic. This directly challenges the Copenhagen interpretation, which has been the dominant school of thought for decades. For many established physicists, their entire careers are built upon the Copenhagen framework. Accepting many worlds would render a lifetime of work, of teaching, and of citation, suddenly built on what might be an incomplete or incorrect basis. It's a paradigm shift so massive that the scientific community has a powerful institutional inertia against it. The second, and perhaps more significant reason, is the profound existential dread this idea can trigger. The concept can be deeply isolating. In an infinite multiverse, every version of you is ultimately alone in their own branch, forever separated from the others. It can also feel nihilistic. If every choice happens, then no choice truly matters. Your successes are guaranteed somewhere, and your failures are inescapable elsewhere, potentially robbing life of its meaning, urgency, and weight for many people. For the guardians of public scientific discourse, this is a dangerous can of worms. Introducing such a destabilizing concept could lead to widespread anxiety or a public distrust in science's ability to provide a stable model of reality. Therefore, the discussion is largely confined to theoretical papers and conferences, treated as a fascinating but untestable thought experiment rather than a potential reality. The truth is softened and filtered, not out of malice, but out of a fear that humanity isn't ready to stare into the infinite abyss of its own possibilities and remain psychologically intact. Yet this invisible shield that has nurtured life for eons is not the constant, unwavering protector we imagine it to be. Scientific data, gathered over decades from satellites and ground observatories, reveals a startling and potentially dangerous truth. Earth's magnetic field is weakening at an accelerating rate. The European Space Agency's Swarm satellite constellation has been meticulously mapping this decline, showing a particularly severe weakening in a vast region stretching from Africa to South America, known as the South Atlantic Anomaly. Here, the field is so diminished that satellites passing overhead must shut down their sensitive electronics to avoid damage from the intensified bombardment of cosmic radiation that bleeds through. This isn't a minor fluctuation, it's a significant loss of protective power that has scientists deeply concerned. This weakening is intrinsically linked to a far more dramatic process, a full magnetic pole reversal. Throughout Earth's history, the North and South magnetic poles have swapped places hundreds of times, with the last reversal occurring roughly 780,000 years ago. These events are not clean, instantaneous flips. Instead, the dipole field we're familiar with, the clear north-south orientation, breaks down into a chaotic, multi-poled mess. During this transition, which can last for centuries, the planet's magnetic shield becomes incredibly weak, perhaps diminishing to just a tenth of its normal strength. For life on Earth, this would mean being exposed to vastly higher levels of cosmic and solar radiation, a shower of high-energy particles that can shred DNA, disrupt global electronic infrastructure, and dramatically increase cancer rates and mutation events in living organisms. The geological record provides a chilling correlation between these magnetic reversals and periods of mass extinction. While not every reversal coincides with a die-off, several major extinction events align suspiciously well with periods of a collapsed magnetosphere. The logic is terrifyingly simple. Without our shield, the planet is subjected to a genetic lottery. Most organisms would succumb to radiation sickness, increased cancer, or the collapse of the food chain as mutagenic effects ripple through ecosystems. But a few, through random chance, might experience beneficial mutations that allow them to thrive in the new, high-radiation environment. our own evolution and the sudden appearance of new species throughout history could be the direct result of these cosmic genetic resets triggered by a failing magnetic field. Given the cataclysmic implications, the question becomes why this isn't a front-page news story and the subject of global preparedness initiatives. The reason is a calculated decision to manage risk on a societal level. For governments and economic institutions, the primary threats are not geological or cosmic. They are financial and social, admitting that a planetary-scale event, one that could collapse power grids, disable global communication, and trigger a public health crisis, is not only possible but potentially imminent, would cause instant and irreversible panic. The stock markets would crater, supply chains would seize up, and civil unrest would become a near certainty as people grapple with an existential threat they are utterly powerless to stop. The very foundations of modern civilization are built on a stable and predictable natural world. Revealing that this stability is an illusion is seen as an unacceptably dangerous truth. Therefore, the research is conducted in relative obscurity, its findings published in specialized journals and discussed at academic conferences far from the public eye. The data is not hidden, but it is certainly not highlighted. Official communications from space agencies and geological surveys focus on the long-term nature of the process, framing it as a curiosity that unfolds over millennia, downplaying the very real and disruptive effects that are already beginning to manifest in our technological systems. This is a classic strategy of information control. It's not an outright lie, but a deliberate softening of the facts to maintain order and prevent the economic collapse that would likely arrive long before the radiation levels became lethal. The public is kept in a state of blissful ignorance, told everything is fine, while behind closed doors, contingency plans are likely being drawn up for a future where the sky itself is no longer our protector. And if the very structure of our reality is under question, then perhaps the most unsettling truth is that we are not alone within it. For decades, the topic of unidentified aerial phenomena was the territory of fringe enthusiasts and science fiction, dismissed by mainstream institutions as fantasy or misidentification. But that official position has begun to crumble under the weight of evidence that can no longer be ignored. Start with the sheer volume of declassified documents from governments worldwide. The United States alone has released thousands of pages through official Freedom of Information Act requests, detailing encounters with objects that defy known physics. These are not vague radar blips, they are reports from highly trained military pilots, describing crafts with no visible means of propulsion performing maneuvers that would turn a human pilot into a fine mist. Instantaneous acceleration, right-angle turns at thousands of miles per hour, and the ability to travel seamlessly from the vacuum of space into the depths of the ocean. The testimony of credible whistleblowers adds a human dimension to these cold documents. Navy Commander David Fravor's account of the 2004 Nimitz encounter is a prime example. A decorated commanding officer of a fighter squadron, he and his wingman were vectored to investigate an object descending from 80,000 feet to hover just above the ocean surface in less than a second. He described a 40-foot-long, white, tic-tac-shaped object with no wings, no exhaust plumes, and no flight control surfaces. It mirrored his aircraft's movements with an almost telepathic precision before vanishing, only to reappear on radar 60 miles away almost instantaneously, a distance that would require travel at over 24,000 miles per hour. His conclusion, and that of his fellow aviators, was unequivocal. This was technology far beyond anything possessed by any nation on Earth. So why does the scientific establishment, which purports to follow the evidence wherever it leads, continue to treat this subject with such open contempt and ridicule? The first layer of the answer involves the protection of military and technological secrets. The most compelling cases almost always involve military personnel and occur in or near restricted airspace and training ranges. The primary concern for any defense apparatus is determining if these objects belong to a terrestrial adversary. Once that possibility is ruled out, the investigation becomes a matter of reverse engineering. If these crafts represent a technology that can neutralize our nuclear arsenals, outpace our fastest jets, and render our radar systems useless, then admitting their existence publicly is to admit a profound and terrifying vulnerability. It is far easier to label the topic as nonsense, pushing it into the cultural gutter, than to acknowledge that we are utterly defenseless against a potential non-human intelligence. National security in this context becomes the perfect excuse for a policy of absolute secrecy and public denial. The second, deeper reason is perhaps more damaging to our collective psyche. It is a defense of human superiority. Our entire modern worldview is built upon the foundation of human exceptionalism. We see ourselves as the pinnacle of intelligence, the masters of our planet, and on a steady, linear path to conquering the stars. The confirmed presence of a non-human intelligence possessing technology that operates on principles we cannot even comprehend shatters that narrative completely. It is a cosmological demotion far more profound than when Copernicus moved us from the center of the universe. It tells us we are not the masters of our home, but potentially just one species among many, and perhaps not even an advanced one. This is an existential shock that many academics deeply invested in the current human-centric paradigm are simply not prepared to handle. To accept it would force a humbling reevaluation of every scientific discipline, from physics and biology to history and theology. The scientific gatekeepers, therefore, employ a strategy of ridicule rather than refutation. They dismiss the evidence without examining it, attack the character of the witnesses, and label any serious inquiry as pseudoscience. This is not the scientific method, it is the defense of a dogma. By controlling the narrative and stigmatizing the topic, they protect their own authority and the comfortable, human-centered story they have built. They are not necessarily evil actors in a conspiracy. Many are simply protecting their life's work from a truth so disruptive that it would invalidate fundamental assumptions across countless fields of study. The greatest cosmic truth they are hiding is not that aliens are among us, but that our understanding of the universe and our place within it is hopelessly naive and incomplete. The refusal to look through the telescope for fear of what they might see is the most unscientific act of all. This brings us to a truth so profound it places the power of the cosmos directly within our own awareness. At the subatomic level, the very act of observation doesn't just measure reality, it actively determines it. This is the core of the Copenhagen interpretation of quantum mechanics, a foundational yet deeply unsettling principle suggesting that a particle exists in a blur of all possible states, a probability wave, until the moment it is observed. Only then does this wave of possibilities collapse into a single, definite reality. It's as if the universe is in a constant state of potential, waiting for a conscious mind to make a choice to look, and in that looking to bring one specific outcome into being. This isn't just philosophical musing, it's demonstrated in laboratory experiments with startling clarity. Consider the quantum Zeno effect, named after the ancient Greek philosopher's paradox about a flying arrow that is motionless at every instant. This phenomenon shows that a constantly observed unstable particle will never decay. By repeatedly and rapidly measuring a quantum system, you can essentially freeze it in its initial state. The continuous act of observation prevents the wave function from evolving and collapsing. It's a breathtaking experimental proof that consciousness, through the mechanism of measurement, has a direct, tangible, and sustained influence on the behavior of matter itself. Our attention doesn't just witness the world, it holds it in place or allows it to change. Now, extend this principle beyond a single particle in a lab. If focused awareness can influence the quantum realm, what could the collective and individual power of human consciousness achieve? This idea forms the basis of numerous ancient spiritual and mystical traditions which have always taught that the mind shapes reality. Modern physics, in its own precise mathematical language, is now whispering the same secret. It suggests that we are not passive inhabitants of a predetermined universe, but active participants in a collaborative, ongoing creation. Our thoughts, our intentions, and our very state of awareness might be subtle but fundamental forces in the cosmic landscape. So why is this extraordinary implication not shouted from the rooftops of every university and published in every mainstream science magazine? The suppression isn't about hiding alien technology or ancient history. It's about something far more immediate: power. A worldview that places consciousness at the center is inherently empowering to the individual. It suggests that your mind is not merely a byproduct of electrochemical processes in your brain, a helpless passenger in a mechanical universe. Instead, you are a co-creator with an innate ability to influence your reality. This directly undermines the materialistic, reductionist paradigm that has dominated science for centuries, which insists that everything, including your thoughts and feelings, is merely the result of blind, purposeless physical interactions. This shift in understanding threatens established systems of control that rely on your belief in your own powerlessness. If people truly internalize that their collective consciousness could shape reality, it would revolutionize everything from healthcare and psychology to economics and governance. Why would you rely solely on external authorities for healing, for knowledge, or for direction if you believed a fundamental creative power resided within? The pharmaceutical industry, segments of the scientific establishment, and even political structures have a vested interest in maintaining the narrative that we are physical machines to be fixed with physical solutions, that our reality is fixed and we must simply adapt to it. Admitting the causal power of consciousness would dismantle this entire framework, transferring agency from external institutions back to the individual. This truth is kept quiet not because it is false, but because it is too liberating. It is the key to a prison we are told does not even exist. Even as we navigate the vastness of space, our entire galactic neighborhood is caught in a relentless, unseen current, pulled toward a point in the cosmic dark with unimaginable force. This is the mystery of the Great Attractor, a gravitational anomaly of such immense power that it is dragging our Milky Way and thousands of other galaxies toward it at a staggering 14 million miles per hour. Located in the general direction of the Centaurus and Hydra constellations, roughly 250 million light-years away, this region represents one of the most profound enigmas in modern cosmology. Its very existence challenges our understanding of the large-scale structure of the universe, and the official explanations for what it might be feel increasingly inadequate, hinting at a reality far stranger than we are being told. The primary challenge in studying this colossal mystery is its location. It lies directly behind the plane of our own Milky Way galaxy, in a zone astronomers call the zone of avoidance. This area is so densely packed with stars, gas, and cosmic dust that it effectively creates a blind spot, blocking our view in visible light. It's as if the universe has placed the most important secret in the one place we can barely see. For decades, this provided a convenient excuse for the lack of detailed public information. However, technology has since advanced. We now have telescopes that can peer through this cosmic veil using infrared, X-ray, and radio wavelengths, which are less affected by interstellar dust. These instruments have begun to map the hidden structures, and what they've found is not a simple answer, but a deeper puzzle. Initial theories suggested the Great Attractor might be a massive concentration of dark matter or a supercluster of galaxies previously obscured from our view. And indeed, surveys have identified a large collection of galaxies in that region, known as the Norma Cluster. But here's where the official story starts to strain credibility. The gravitational pull required to move thousands of galaxies, including our own, is orders of magnitude greater than what even a massive supercluster can generate. The numbers simply don't add up. The observed mass is there, but it is nowhere near enough to account for the phenomenal force being exerted. This leaves scientists with two uncomfortable possibilities. Our understanding of gravity is fundamentally flawed on a cosmic scale, or there is something else there, something of inconceivable density and power that we cannot directly see. This is where the speculation veers into extraordinary territory. Could the Great Attractor be a singularity on a scale we can barely comprehend? Not merely a supermassive black hole, but an ultramassive black hole, a gravitational engine so vast it could anchor an entire supercluster. Or perhaps it is something even more exotic, a cosmic defect in the fabric of space-time, a remnant from the Big Bang itself, or even a gravitational nexus, a point where the pull from other dimensions or parallel universes bleeds into our own. The most radical theory proposes it isn't a structure at all, but a gateway or a tear in the cosmic canvas, a place where the very rules of physics as we know them break down, explaining its impossible gravitational signature. The reason these more thrilling possibilities are suppressed and relegated to scientific whispers is twofold. Firstly, admitting that such an object could exist would force a complete rewrite of astrophysics and cosmology. It would upend models that have taken decades to build and upon which countless careers and reputations are founded. The academic establishment has a powerful inertia, a resistance to ideas that are too disruptive, regardless of how well they might fit the anomalous data. Secondly, and more critically, is the matter of classification. The tools that have pierced the zone of avoidance, like space-based X-ray observatories, are often dual-use technologies with significant defense applications. The full-resolution data they collect is likely considered a matter of national security by several world governments. The precise mapping of such a powerful gravitational phenomenon could have implications for deep space navigation, weapon targeting systems, and the understanding of fundamental forces that could be weaponized. Therefore, the most revealing data is likely kept within classified circles, analyzed by defense contractors and intelligence agencies rather than published in open astrophysical journals for the world to see. The public is given the sanitized version, a discussion of dark matter and superclusters, while the truly unsettling truth about what pulls us through the void remains a closely guarded secret. Now consider the very fabric of empty space. It isn't empty at all. According to quantum field theory, what we perceive as a vacuum is actually a seething, bubbling sea of energy. A quantum foam where particles and antiparticles constantly pop into and out of existence in an endless dance. These are quantum fluctuations, and they represent a background energy present throughout the entire universe, even at absolute zero. This is zero-point energy, and its theoretical potential is nothing short of miraculous. The energy density contained within a single cubic centimeter of this so-called empty space is calculated to be vast enough to boil all the oceans of Earth in an instant. Tapping into this fundamental energy field would mean accessing a limitless, clean, and ubiquitous power source, effectively ending our dependence on fossil fuels, ending energy scarcity, and revolutionizing every aspect of human civilization. The principles behind harnessing this energy are not just theoretical fantasy. The Casimir effect provides a tangible, laboratory-verified glimpse into this power. When two uncharged, perfectly smooth metal plates are placed incredibly close together in a vacuum, they are pushed toward each other by a mysterious force. This happens because the tiny space between the plates restricts the types of quantum fluctuations that can occur there, while the fluctuations outside the plates remain unrestricted. The greater external pressure literally squeezes the plates together, converting the energy of the quantum vacuum into measurable mechanical motion. It's a direct, repeatable demonstration that this energy is real and can be interacted with, proving that the power to run our world is literally all around us, hidden in the void. Given this breathtaking potential, the obvious and urgent question is why we don't see zero-point energy devices powering our homes and cities today. The answer lies not in the limits of physics, but in the ruthless economics of power and control. Our entire global economy is built upon the scarcity model of energy. Trillions of dollars in infrastructure, corporate valuations, and geopolitical influence are tied to the extraction, refinement, and sale of oil, gas, and coal. The industries that control these resources are among the most powerful and politically connected entities in human history. To them, free and unlimited energy isn't a utopian dream. It is an existential threat that would obliterate their business models and collapse their stranglehold on the global economy overnight. The suppression of this technology is a multifaceted campaign. Inventors and researchers who claim to have made breakthroughs in over-unity or zero-point energy devices often report a familiar pattern of intimidation, mysterious lab fires, unexplained confiscation of prototypes, and sudden withdrawal of funding. Their patents are frequently classified under national security statutes or rejected under dubious pretexts, preventing the technology from ever seeing the light of day. The media, often funded by advertising from these same energy interests, is complicit, either ignoring these stories entirely or systematically ridiculing them, ensuring the public dismisses the entire concept as pseudoscience. This creates a powerful cultural and institutional barrier that stifles both innovation and open discussion, but the conspiracy goes deeper than corporate greed. For governments, the control of energy is synonymous with the control of populations. A society that has to pay for power that relies on a centralized grid is a society that is easier to manage, monitor, and tax. Free energy would decentralize power literally and figuratively, empowering individuals and small communities to become truly independent. It would break the leverage that nations have over one another in oil and gas disputes and would fundamentally destabilize the global balance of power. The national security state views such a disruptive technology not as a liberation, but as a profound threat to global stability and its own authority. Therefore, any genuine research that gets too close to a practical application is likely co-opted, classified, and buried deep within black-budget military projects, where its potential can be weaponized rather than shared for the betterment of humanity. This deliberate suppression is perhaps the greatest crime against humanity, a silent war waged to keep us enslaved to a system of artificial scarcity. We are told that renewable energy like solar and wind are the answers, and while they are a step forward, they are still beholden to the elements and require vast mining operations and land use. They are acceptable to the powers that be because they still operate within a framework of ownership and distribution that can be monetized and controlled. Zero-point energy represents a paradigm so complete it would render all of that obsolete. The truth is hidden not because it is impossible, but because its realization would shatter the very chains of economic and political control that have defined the modern era, offering a freedom that those in power are terrified we might actually achieve. Yet we are told with unwavering certainty that the entire cosmos exploded into being from a single point, an event we call the Big Bang, and that a fraction of a second later, it underwent a period of impossibly fast expansion known as cosmic inflation, smoothing everything out into the universe we see today. This story is presented as settled fact, the cornerstone of modern cosmology. But what if this foundational pillar is cracking? A growing number of dissenting scientists point to stubborn anomalies that the standard model simply cannot explain, suggesting that cosmic inflation, and perhaps the Big Bang itself, never happened the way we've been told. The first major crack in the facade appears when we look at the universe's baby picture, the cosmic microwave background radiation. This faint glow is the leftover heat from the early universe, and according to the inflation model, it should be almost perfectly smooth, with tiny, random fluctuations that inflation stretched to cosmic scales. But the data tells a different story. The fluctuations aren't entirely random. There are large-scale asymmetries, a mysterious cold spot that is far too large and cold to be explained by standard physics, and strange alignments in the polarization of the light that defy probability. It's as if we're looking at a fingerprint that doesn't match the suspect we have in custody. The patterns suggest something more complex, perhaps even cyclic, at work. These anomalies have led some of the most brilliant minds in physics to propose a radical alternative, conformal cyclic cosmology, or CCC, put forward by Nobel laureate Sir Roger Penrose. His model does away with the need for a definitive beginning or a rapid inflationary period. Instead, it proposes an endless cycle of universes or aeons. In this view, our universe will eventually expand into an infinite, cold, empty state. But infinity has a funny way of resetting the scales. In this vast emptiness, the distinction between a massive black hole and a single electron vanishes. Space loses all sense of scale, allowing this dead, expanded universe to become the high-energy, ultra-dense Big Bang for the next eon in the cycle. The radiation from the death of black holes in a previous eon could even imprint itself as the anomalous patterns we see in our own cosmic microwave background, which Penrose and his colleagues claim to have found evidence for. So why is this elegant, mind-bending model not the subject of every cosmology conference? The answer is a deeply ingrained scientific dogma. The Big Bang Theory, complete with its inflationary add-on, has become the ruling paradigm. Entire careers, billions of dollars in research funding, and thousands of academic papers are built upon its framework. To challenge it is not merely to present a new idea, it is to threaten a vast and powerful intellectual empire. Young researchers quickly learn that pursuing heterodox ideas like CCC is a professional death sentence, a surefire way to be denied tenure, funding, and publication in prestigious journals. The peer review process, meant to ensure quality, often acts as a gatekeeping mechanism to enforce orthodoxy and filter out ideas that are too disruptive. This isn't science, it's scholasticism. It's a priesthood protecting its doctrine. The insistence on a definitive beginning aligns uncomfortably well with religious creation myths, offering a scientific-sounding story that neatly fits a beginning, middle, and narrative we find comforting. A truly cyclic universe without a start or finish is existentially unsettling. It removes humanity from a unique timeline and places us in an endless, recurring loop, challenging our desire for a singular, special creation. The scientific establishment, in its refusal to seriously entertain these alternatives, isn't just protecting a theory. It's protecting a worldview, one that keeps the cosmos comfortably contained within a box of our own making, and in doing so, may be preventing us from glimpsing its truly magnificent eternal nature. But perhaps the most elusive substance in the universe isn't a substance at all, but a shadow from a world just out of reach. We call it dark matter, this invisible stuff that makes up over 80% of all matter, whose presence we only infer through its immense gravitational pull on galaxies. For decades, the scientific establishment has pursued a single solution, a new, undiscovered particle like a WIMP or an action that simply hasn't been detected yet. But after billions of dollars and decades of increasingly desperate searches in deep underground labs and with powerful particle colliders, we have found absolutely nothing. Not a single trace. This fruitless hunt points to a thrilling and radical possibility. What if we're looking in the wrong dimension entirely? What if dark matter isn't made of exotic particles in our universe, but is instead ordinary matter from a parallel reality, bleeding through into ours and making its presence known only through gravity, the one force that might be able to bridge the gap between worlds? This idea, while seemingly lifted from science fiction, is grounded in legitimate theoretical physics, particularly within the framework of string theory and the concept of the multiverse. In these models, our universe is not a lone entity but one of perhaps infinite universes, often imagined as membranes or brains floating in a higher dimensional space. Normally, these brains are separate, but they could occasionally vibrate, warp, or even collide. During such an event, matter from one brain could gravitationally influence matter in another. To us, that matter would be utterly invisible. We couldn't see it, touch it, or detect it with any instrument designed to find particles in our own dimension. Its only interaction with our world would be through the fabric of spacetime itself, gravity. This elegantly explains why dark matter's effects are purely gravitational and why it has evaded every other attempt to find it. We're not searching for a ghost particle, we're feeling the weight of an entire alternate Earth, an alternate sun, an alternate galaxy, superimposed right on top of our own. The implications of this are staggering. It means that every single one of us might be coexisting with countless other versions of reality, all occupying the same space but separated by a dimensional veil so thin that only gravity can seep through. The dark matter halo that envelops our Milky Way galaxy could be the gravitational shadow of a parallel Milky Way, its stars and planets intertwining with ours in a cosmic dance we are only barely aware of. This isn't just a neat trick of cosmology, it redefines our very existence, suggesting that solitude is an illusion and that we are forever brushing shoulders with worlds unseen. So why is this compelling and elegant theory not the leading candidate for solving the dark matter mystery? The suppression is not one of malicious intent, but of professional and financial inertia. The search for a particle has become a multi-billion-dollar industry. Vast experiments like the Large Hadron Collider, countless research grants, and entire academic careers are built upon the assumption that dark matter is a particulate substance within our own universe. To pivot to a theory that cannot be tested with a particle detector, a theory that suggests the answer lies in the architecture of reality itself, would render decades of expensive work potentially obsolete. The scientific community, like any large institution, is resistant to ideas that threaten its foundational investments and the reputations of its most prominent figures. Accepting that dark matter is extra-dimensional would be an admission that we've been pouring resources down a rabbit hole for generations, a humbling pill that many are simply not willing to swallow. Furthermore, this theory ventures into territory that is notoriously difficult to test with our current technology, making it easy for detractors to dismiss it as untestable and therefore unscientific. But this dismissal is a self-fulfilling prophecy. By refusing to fund the theoretical and mathematical work needed to develop testable predictions for the brain-world model, the gatekeepers ensure it remains on the fringes. They protect the paradigm of particle physics, but in doing so, they may be blinding us to a truth far more magnificent and complex: that the missing mass of the universe isn't missing at all. It's all around us, a silent, ghostly testament to the infinite layers of reality, forever felt but never seen. Yet we are encouraged to see the cosmos as a cold, mechanical clockwork, a vast and empty expanse of mindless matter governed by indifferent physical laws. But what if the opposite is true? What if the universe is not dead but profoundly, astonishingly alive? This is the spine of cosmic truth number 17, a concept that emerges not from mysticism, but from the cold, hard data of our most advanced telescopes and the startling patterns they reveal. When we map the large-scale structure of the universe, we find a cosmic web of galaxies strung along filaments of dark matter, intersecting at massive nodes and surrounded by vast, empty voids. This structure is not random, it is a complex hierarchical network, and when neuroscientists map the human brain, they find an eerily identical architecture, a web of neurons connected by axons, intersecting at synapses and surrounded by supportive glial cells. The two images, one of the cosmos and one of the cortex, are virtually indistinguishable to the naked eye. The universe, in its grandest design, mirrors the very organ we use to perceive it. This is more than a curious coincidence. It is a potential clue to the deepest nature of reality. The similarity in structure suggests a similarity in function. Just as the neural network of your brain generates your conscious experience, the cosmic web of galaxies could be the physical substrate of a universal consciousness. This idea, known as panpsychism, proposes that consciousness is not a rare and late emerging property of complex biological brains, but a fundamental feature of the universe, present to some degree in all matter. From the spin of an electron to the swirl of a galaxy, a faint hum of awareness permeates everything. In this view, the universe isn't a machine that somehow stumbled into creating observers. It is an observer itself, a single, unfolding conscious experience of which we are a small, self-aware part. The evidence for this is not just visual. The mathematical models that describe the growth of galaxies and the flow of information in neural networks are strikingly similar. The same laws of physics that govern the formation of stars seem to govern the firing of neurons. This points toward a universal set of organizational principles that apply equally to the very large and the very small, to the inorganic and the organic. It suggests that life and mind are not accidents in a dead universe, but are baked into its fundamental recipe from the very beginning. So why is this breathtakingly beautiful and elegant idea dismissed as fringe nonsense by the mainstream scientific establishment? The resistance is a fierce defense of the mechanistic paradigm, the 400-year-old worldview that has been the engine of modern science. This paradigm insists that only matter and energy are real, and that everything, including consciousness, must be reduced to and explained by physical interactions. To suggest that consciousness is a primary, irreducible element of the cosmos is heresy. It smacks of vitalism, the discredited idea that life is driven by a non-physical spark, and it threatens to drag science back into the realm of the supernatural in the eyes of its staunchest defenders. For a career academic whose entire life's work is built upon the materialist foundation, accepting panpsychism is professional suicide. It would invalidate reductionist approaches to neuroscience, physics, and philosophy, forcing a humbling admission that our current models are incomplete. Grant money, publication opportunities, and peer respect are all tied to working within the accepted framework. Proposing that the universe is alive is a quick way to be labeled a crank and exiled from serious discourse. Furthermore, this idea is deeply unsettling to the human ego. We are comfortable being the lone spark of awareness in a silent universe, the pinnacle of creation. The thought that we are merely one ripple in a vast ocean of universal consciousness can feel diminishing, even if it is ultimately a more connected and holistic vision of reality. The truth is suppressed not because it is false, but because it forces a humility that the current guardians of scientific orthodoxy are not yet ready to embrace, protecting a dying world view at the expense of a more magnificent and complete understanding of our alive and conscious cosmos. Gravity feels like the most reliable force in our daily lives, the invisible hand that keeps our feet on the ground and the planets in their orbits. We are taught it is one of the four fundamental forces of the universe, a pillar of physics first described by Newton and later refined by Einstein's theory of general relativity. But what if this entire framework is built on a misconception? What if gravity isn't a fundamental force at all, but merely a side effect, an emergent phenomenon arising from a much deeper and more bizarre layer of reality? This isn't science fiction, it's a serious proposition gaining traction in theoretical physics, suggesting that the force we know so well is in fact a grand and convincing illusion. One of the most compelling alternative theories is entropic gravity, proposed by physicist Eric Verland. Imagine the universe is not made of particles and forces, but of information. At the most fundamental level, reality might be composed of tiny bits of data, and the laws of physics could be analogous to the laws of thermodynamics that govern heat and energy. Verlin's radical idea is that gravity is not a force that pulls objects together, but a consequence of entropy, the natural tendency of systems to move toward disorder. When two masses are near each other, the arrangement of this underlying information changes in a way that increases entropy, and this statistical tendency manifests as what we perceive as gravitational attraction. It's not that mass tells space-time how to curve, it's that the collective behavior of countless bits of information creates the effect of curvature and force. In this view, gravity is no more a fundamental force than the pressure of a gas, it's an average behavior emerging from countless microscopic interactions we cannot yet see. This concept dovetails perfectly with another revolutionary idea, the holographic principle. This principle suggests that our three-dimensional universe, with all its rich complexity including gravity, might actually be a projection of information encoded on a two-dimensional surface at its boundary, much like a hologram emerges from a flat sheet of film. If this is true, then gravity within our three-dimensional world is simply a manifestation of processes happening on that distant two-dimensional surface. It is a force that feels real to us, but it is derivative, a shadow of a deeper reality. The mathematics supporting this is not just speculative, it has successfully been used to describe the behavior of black holes, where the information about everything that falls in is theorized to be encoded on its two-dimensional event horizon. This provides a tantalizing hint that the principle might apply to the entire cosmos. The evidence for this illusory nature of gravity is not just theoretical. Astronomers have long observed a discrepancy in the motion of galaxies. They rotate so fast that they should fly apart, but they don't. The prevailing explanation for decades has been the existence of dark matter, an invisible substance providing extra gravity. However, models based on entropic gravity can explain these same galactic rotations without needing to invoke a single particle of dark matter. The observed motion fits perfectly with the idea that gravity is an emergent phenomenon, not a fundamental force requiring unseen matter to make the math work. This suggests we might have been inventing an entire universe of dark matter to explain a flaw in our understanding of a force that doesn't even exist in the way we think it does. Given the power of these theories to solve major cosmic puzzles, the obvious question is why they haven't toppled the established model. The resistance is not about the strength of the ideas, but about the sheer weight of the existing scientific infrastructure. General relativity has been the cornerstone of modern cosmology for a century. Thousands of careers, countless PhDs, and billions of dollars in research funding are invested in its framework. Admitting that gravity is an emergent illusion would render a vast portion of this work intellectually obsolete. Textbooks would need to be rewritten. Decades of research based on the assumption of dark matter would be called into question, and the entire field of physics would undergo a paradigm shift more profound than the move from Newtonian mechanics to quantum theory. For the established scientific community, this is a terrifying prospect. It's a threat to reputations, to funding, and to the very identity of physics as it has been practiced for generations. The peer review system, designed to ensure quality, often acts as a system of peer enforcement, protecting the status quo from radical change. Proposals that challenge gravity's fundamental nature are often met with intense skepticism, difficulty in publishing, and a lack of research grants. This isn't necessarily a malicious conspiracy. It is the natural inertia of any large, entrenched institution facing a revolution. The guardians of the old paradigm are protecting the world they built, a world that has been incredibly successful, even if it is now showing cracks. The truth about gravity is suppressed not because it is false, but because accepting it would require a humility and a willingness to start over that the current establishment is not yet ready to embrace. Imagine the fabric of space-time not as a smooth, unbroken sheet, but as a cosmic battlefield littered with the frozen scars of creation itself. These are cosmic strings' theoretical defects, unimaginably thin filaments of pure energy thinner than a proton, but stretching across the entire universe. They are thought to be remnants from the universe's first fractional seconds, when the fundamental forces of nature underwent a traumatic phase transition, like cracks forming in ice as water freezes. A single inch of such a string would possess a mass of staggering proportions, potentially billions of tons, making them the most massive and dense objects in all of existence relative to their size. Their gravitational influence would be so intense that they wouldn't just bend space-time, they would pleat it, folding the cosmos in ways that defy our everyday intuition. The potential of these strings is where the science ventures into the realm of what we might call magic. Because they warp space-time so severely, a cosmic string could act as a natural time machine. The mathematics is clear. If two strings were to pass by one another at a significant fraction of the speed of light, or if a single string were to form a loop, they would create closed time-like curves in their wake. This is the complex physicist's term for a path through space-time that loops back on itself, allowing for travel into the past. You wouldn't need a fancy machine with glowing lights and spinning rings. You would simply need to navigate a spacecraft in a precise figure-8 pattern around these moving strings. The geometry of the universe itself would do the rest, effectively turning the entire cosmos into a navigable timeline where the past and future are just coordinates on a map. This isn't just a fun thought experiment, it's a legitimate area of study for a handful of bold theoretical physicists. The equations work, the physics is sound, albeit operating at energy scales we can scarcely imagine replicating. The logical next step would be a concerted, well-funded global effort to detect these strings through their subtle gravitational lensing effects on distant galaxies or their imprint on the cosmic microwave background. Yet this research languishes in obscurity, relegated to a few obscure papers and treated as the embarrassing cousin of more respectable cosmology. Proposals for dedicated observation missions are routinely denied funding, and physicists who pursue this line of inquiry often face quiet ridicule from their peers, their professionalism questioned for daring to take the idea of time travel seriously. The reason for this suppression is not that the science is weak, but that its implications are existentially dangerous for the established order. Think of the sheer chaos that would ensue if the technology for manipulating time became a tangible possibility. The entire foundation of human society, our laws, our history, our very concept of cause and effect is built upon the unshakable linearity of time. What happens to justice if a criminal can undo their crime? What happens to the economy if someone can go back and invest in the right company? The potential for paradox, for catastrophic alteration of the timeline, and for the ultimate weaponization of history itself is a threat that dwarfs any nuclear arsenal. For any government or shadow organization aware of this theoretical potential, the only logical course of action is to ensure it remains theoretical. They cannot risk a rival power discovering the secret first, and they certainly cannot risk that knowledge ever becoming public. So the field is strategically marginalized, mocked into obscurity in academic circles to ensure that the brightest minds are steered toward less volatile pursuits, all to protect the fragile, linear narrative of human history from being unraveled by the very threads that might have woven it together in the first place. We've been asking the wrong question for decades. The puzzle isn't where everybody is, it's why they're so quiet. The Fermi paradox, which highlights the baffling contradiction between the high probability of alien civilizations and our utter lack of contact with them, isn't a genuine mystery. It's a carefully constructed lie, a narrative designed to keep us placidly searching the stars while the truth remains hidden right here. The silence isn't natural, it's engineered. The most plausible explanation is that we are not merely uncontacted but deliberately isolated, living inside a galactic quarantine or bound by secret treaties we were never meant to know about. Consider the sheer absurdity of our situation. Our galaxy is over 13 billion years old and contains hundreds of billions of stars with an even greater number of potentially habitable planets. Life on Earth sprang up almost the instant our planet cooled enough to allow it, suggesting the process of abiogenesis is not a miraculous fluke but a natural, almost inevitable chemical progression. Given the immense head start the universe had, intelligent species should have arisen millions, if not billions, of years before us. Their technology would be so advanced as to be indistinguishable from magic, and their presence should be as obvious and unavoidable as the stars themselves. Yet we hear nothing, we see nothing. This profound silence is not evidence of our solitude, it is the signature of a policy. It is the sound of a zoo being carefully managed or a preserve being kept pristine. This leads to the chilling possibility of a galactic quarantine, often referred to as the zoo hypothesis. In this scenario, a consortium of advanced civilizations is fully aware of our existence but has agreed to a strict non-interference directive. They observe us from a distance, allowing our species to develop or destroy itself without outside influence. The reason could be ethical, akin to a prime directive to avoid contaminating a developing culture. Or it could be far more pragmatic. They see us as dangerously volatile, a primitive species still governed by tribalism, violence, and self-destruction. To them, we might be the equivalent of a dysfunctional, armed camp, best left contained until we evolve beyond our self-imposed limitations or until we inevitably burn ourselves out. Our radio signals and probes haven't been answered not because no one is listening, but because everyone has agreed not to answer. But what if the quarantine isn't just observational? What if it's actively enforced by a cover-up here on Earth? This is where organizations like the Search for Extraterrestrial Intelligence, or SETI, come into play. For decades, SETI has been the public face of the hunt for alien life, tirelessly scanning the heavens for any whisper of a signal. Yet despite all this effort, the official line remains that they have found nothing. But what if their true purpose is not to find a signal, but to act as a gatekeeper, ensuring that if a signal is detected, it is controlled and its revelation managed? SETI continued, a highly publicized failure maintains the public illusion that space is empty, effectively gaslighting the entire population into believing we are alone. It's the perfect cover. By monopolizing the search and consistently reporting negative results, they discredit any independent discoveries and maintain control over the narrative. This deception likely goes far beyond a single organization. Whistleblowers from within military and intelligence agencies have for years claimed that the real contact isn't happening with radio telescopes, it's happening in clandestine meetings. The allegation is that secret treaties have already been signed between world governments and non-human intelligences. These agreements, if they exist, would be the most closely guarded secret in human history, as their disclosure would cause the immediate collapse of every religious, economic, and political system on the planet. The terms of such a treaty could be anything from allowing limited genetic experimentation on human populations in exchange for advanced technology, to an agreement that we will not be allowed to become a spacefaring species until we meet certain conditions of global unity. The very people we trust to protect us may have already negotiated our future without our knowledge or consent, making the entire human population subjects in a cosmic agreement we never signed. The reason this truth remains buried is the ultimate exercise in damage control. For the powers that be, the admission that we are not alone but are considered too primitive or too dangerous to join the galactic community is an unbearable blow to human pride. It would instantly shatter the authority of every institution on Earth, from governments and militaries to religions and scientific bodies, all of which are founded on the premise of human supremacy. The social and economic chaos that would follow such a revelation is unimaginable. Therefore, the silence is maintained. The Fermi paradox is perpetuated as an intellectual curiosity, a fun puzzle for physicists to debate, while the real answer, that we are being kept in a carefully constructed dark is hidden in plain sight. Our continued search for signals is not a quest for truth. It is a performance, a theatrical production designed to keep us looking up at the stars so we never think to look behind the curtain. We've been taught that the speed of light is the universe's ultimate speed limit, an unchanging constant woven into the very fabric of reality. This figure, 299,792,458 meters per second, is presented as a sacred number, the golden rule upon which Einstein's theory of relativity and all of modern cosmology is built. But what if this cornerstone of physics is not so set in stone? Historical records and a growing body of controversial experiments suggest that the speed of light might not be constant at all, but a variable that has fluctuated over the vast expanse of cosmic history. This isn't a minor adjustment, it's a revelation that would unravel our understanding of the universe from the Big Bang to the nature of black holes. The first cracks in this constant appeared not in a modern lab, but in the notebooks of the very scientists who helped establish it. In the late 19th century, a physicist named Walter Ritz proposed an emission theory, suggesting that the speed of light was dependent on the velocity of its source, much like a baseball thrown from a moving train. While this idea was eventually overshadowed by Einstein's work, it never completely disappeared. More startling are the meticulous measurements taken by the Nobel Prize-winning physicist Albert Abraham Michelson, who dedicated his life to refining the value of c. Across multiple decades, his results showed slight but persistent variations, differences he initially attributed to experimental error. But what if the error wasn't in his equipment, but in our assumption that the value was fixed? Later, in the 1930s, a physicist named Herbert Ives repeated the Michelson-Morley experiment and found yet another slightly different value, a finding he struggled to publish as the scientific consensus solidified around Einstein's constant. This historical data finds a disturbing parallel in modern astronomical observations. When we look at the light from the most distant quasars, billions of light years away, we can analyze their absorption spectra, the unique fingerprints of elements like iron and nickel imprinted on the light. The fine structure constant, a fundamental number that governs the strength of electromagnetic interactions and is directly tied to the speed of light, appears to have been different in the ancient past. This isn't a fringe claim, it's based on data from the world's most powerful telescopes, including the Very Large Telescope in Chile. The observed shifts are tiny, but they are statistically significant and consistent across multiple lines of sight. The most straightforward interpretation is that the fundamental constants, including the speed of light, were not always what they are today. The universe in its youth may have operated under slightly different rules. So why is this monumental possibility met with such fierce resistance and outright suppression from the physics establishment? The first reason is the monumental investment in the status quo. The entire edifice of 20th and 21st century physics is constructed upon the foundation of a constant c. Einstein's theory of relativity is arguably the most successful and celebrated theory in all of science. Its equations are used to calibrate GPS satellites, predict the behavior of particles in accelerators, and model the evolution of the entire cosmos. To admit that the speed of light might be variable would be to pull out the bottom card from this gigantic house of cards. General relativity would need a radical overhaul, if not a complete replacement. The careers of thousands of physicists, the validity of countless PhD theses, and the conclusions of decades of research would be instantly thrown into question. The academic and institutional inertia against such a paradigm shift is almost unimaginably powerful. The second, more profound reason for the suppression is the existential threat it poses to our cosmic narrative. A variable speed of light offers an elegant and powerful solution to some of cosmology's greatest puzzles, most notably the horizon problem. This problem asks how regions of the universe on opposite sides of the sky have exactly the same temperature and properties when, according to the standard Big Bang model, there hasn't been enough time since the beginning of the universe for light or heat to travel between them and equalize. The mainstream solution is an add-on called inflation, a period of impossibly fast expansion just after the Big Bang. But inflation itself is a theoretical band-aid with its own set of problems. A variable speed of light provides a much simpler answer. In the very early universe, light traveled much faster. This would have allowed everything to communicate and thermalize instantly, solving the horizon problem without the need for an unproven inflationary period. The fact that this elegant solution is so vehemently dismissed reveals a deeper truth. The guardians of cosmology would rather protect a complex and problematic model they built than accept a simpler, more beautiful solution that dismantles their life's work. The speed of light is kept constant not by nature but by decree to preserve a story of the universe we have become too comfortable and too invested to change. Consider for a moment that the most fundamental experience of life, its ending, might be the greatest illusion of all. This is the unsettling promise of quantum immortality, a theory that suggests your conscious awareness can never truly cease. It proposes that at the moment of any life-threatening event, your consciousness does not wink out of existence but instead seamlessly shifts to a parallel universe where you survive. You are, in a sense, always the version of you that lives to see the next moment, forever riding a wave of reality where death is only ever something that happens to other versions of yourself in branches of the multiverse you no longer inhabit. This idea finds its most chilling support in a thought experiment known as the quantum suicide machine. Imagine a device is built that is triggered by the decay of a single radioactive atom. In any given second, the probability that the atom decays is 50%. If it decays, the gun fires. If it doesn't, it doesn't. The experiment is set up so that after each second, the experiment is reset with a new atom. Now, from the perspective of an outside observer, this is a macabre game of Russian roulette. They would see you step into the machine and within a few seconds almost certainly hear a gunshot. They would witness your death and mourn you, but from your perspective, something very different would happen. You would hear the first click of the trigger as the atom does not decay. You would breathe a sigh of relief, then the machine resets, another click, then another and another. From your point of view, the gun never fires. You would experience a seemingly impossible run of luck, surviving countless 50-50 chances in a row, because in the branching timelines where the gun does fire, your consciousness is no longer there to experience it. You only experience the realities in which you remain alive. The scientific community approaches this idea with a mixture of intellectual fascination and profound ethical horror. The reason it remains a thought experiment and will never be a research paper is straightforward. It is utterly untestable in any ethical framework. To even attempt to gather data would be to commit an act of unimaginable cruelty, creating a device whose sole purpose is to kill countless versions of a sentient being. Furthermore, the theory creates a terrifying solipsistic prison. If true, you could be the only truly immortal consciousness in existence, surrounded by what appear to be other people who live and die, but who may merely be projections or temporary companions in your endless journey through the multiverse. Everyone you have ever loved and lost would not be gone. They would simply be in a branch of reality you can no longer access, forever separated from you by an uncrossable dimensional divide. This leads to the deeper, more existential reason the theory is suppressed. It makes a mockery of the scientific method itself. Science relies on objective, repeatable experiments that yield the same results for all observers. Quantum immortality shatters this principle. In the suicide machine experiment, the observer outside the box and the consciousness inside the box have two completely irreconcilable, yet equally real experiences. There is no shared objective outcome. This introduces a frightening subjectivity into the heart of reality. suggesting that truth itself might be personal and unshareable. For a discipline built on shared truth and consensus, this is a paralyzing concept. It's far easier to relegate quantum immortality to the realm of philosophical parlor games than to confront its implications, which suggest that the core of our existence, our consciousness, operates by rules that fundamentally undermine everything we believe about life, death, and a shared objective universe. But what if the most profound secrets of our cosmic neighborhood aren't hiding on a nearby planet or moon, but in the deepest, darkest freeze of space far beyond the orbit of Pluto? This is the realm of the Oort cloud, a vast and theoretical shell of icy planetesimals that is thought to envelop our entire solar system like a colossal, distant fog. It's a place so remote that it marks the very boundary of the sun's gravitational influence, a trillion frozen worlds waiting in the profound silence. Mainstream astronomy tells us these are simply leftover building blocks from the solar system's formation, pristine and untouched for billions of years. But this explanation feels increasingly inadequate, a convenient label for what might be the greatest archaeological site in human history, a cosmic attic filled not with junk, but with the artifacts of those who came before us. The very nature of the Oort cloud makes it the perfect long-term storage facility for the universe. Its objects are spread over such an immense volume of space that they are virtually immune to the collisions and orbital chaos that characterize the inner solar system. Anything placed there will be preserved in a near-perfect state of cryogenic suspension for eons. If an ancient spacefaring civilization ever passed through our system millions or even billions of years ago, the outer Oort cloud would be the ideal place to leave a beacon, a time capsule, or a monitoring outpost. It would be safe, stable, and undetectable to a species just beginning to look up at the stars. These wouldn't be crashed ships or abandoned bases. They would be deliberately placed artifacts designed to last until a species like ours became technologically mature enough to find them. This idea transforms every known comet from a simple dirty snowball into a potential Trojan horse. When a comet from the Oort cloud is nudged by a passing star's gravity and begins its long fall toward the inner solar system, we study its coma and tail for clues about the early solar system. But we are not looking for the right things. We are searching for natural chemistry, not artificial signatures. What if some of these icebergs are not entirely ice? What if they contain cores of manufactured material disguised as natural objects, their true purpose only activated by the warmth of the sun? The strange behavior of certain comets, sudden unexplained outbursts, odd non-gravitational accelerations, or peculiar compositions could be misdiagnosed natural phenomena, or they could be the first faint whispers of technology so old it predates humanity itself. This leads to the most troubling question of all. If there is even a remote possibility that such relics exist, why are our space agencies not launching missions to investigate? The official answer is always one of practicality and cost. The distances are too vast, the travel times too long, and the targets too small and too numerous. A probe would take thousands of years to reach the inner Oort cloud with current technology. This is presented as an insurmountable barrier, a conversation ender. But this dismissal feels suspiciously convenient. It ignores the rapid pace of advancements in propulsion concepts, from nuclear thermal rockets to solar sails, that could make such a journey feasible within a century. The real barrier may not be engineering but intention. There is a compelling argument to be made that our exploration of the solar system is being subtly guided away from these potentially disruptive regions. Every mission profile, every target selection by agencies like NASA and the European Space Agency is focused inward, on Mars, the asteroids, the gas giants, and their moon. These are safe targets. We might find microbes or subsurface oceans, discoveries that can be neatly folded into our existing scientific paradigms. Finding a fossil is one thing. Finding a functional alien artifact is something else entirely. Such a discovery would be an instantaneous paradigm shift, a cultural and scientific earthquake that would render every government and scientific institution instantly obsolete in the eyes of the public. The knowledge that we are not just not alone, but that others have been here watching for longer than our species has existed, is a truth that would be impossible to control. Could it be that the continued focus on Mars and the Moon is a deliberate strategy, a way to keep the public and the scientific community focused on goals that are ambitious enough to inspire but safe enough to manage? By controlling the narrative of discovery, the powers that be can ensure that any truly transformative truth is found on their terms, if it is found at all. The outer solar system, with its trillion potential hiding places, remains the ultimate blind spot, a frontier so vast and difficult to explore that it provides the perfect excuse for not looking. We are told the Oort cloud is too far away to be relevant, a message repeated so often and so confidently that we have stopped asking why we aren't even trying. This isn't just an oversight, it's a policy, and it ensures that the most important discoveries in human history remain exactly where they were left, in the deep freeze, waiting for us to become brave enough to finally go and look. The idea of journeying through time has long been captured in our stories as the ultimate human fantasy, a dream of steam-powered machines and flashing lights. But what if the reality is far less theatrical and infinitely more unsettling? What if time travel isn't a future technology waiting to be invented, but an ongoing phenomenon that has been occurring for decades, hidden in plain sight through a combination of bizarre accidents, clandestine military projects, and the mind-bending rules of quantum physics itself? The evidence is not locked in a distant future, it's buried in declassified documents and whispered in the accounts of those who claim to have experienced the impossible. Consider one of the most persistent and chilling rumors to emerge from the shadows of the Second World War, the Philadelphia experiment. According to various accounts, in 1943, the U.S. Navy allegedly sought to render a warship, the USS Eldridge, invisible to radar. Using a theory from Einstein's unified field theory, they generated an intense electromagnetic field around the destroyer escort. The story goes that the experiment succeeded far beyond their wildest fears. The ship didn't just become radar invisible, it reportedly vanished entirely from the Philadelphia Naval Yard, only to momentarily reappear in the harbor at Norfolk, Virginia, over 200 miles away before flashing back to its original location. Crew members were said to have suffered horrific consequences, with some found fused to the metal bulkheads of the ship itself, others driven insane, and a few claiming to have experienced periods of time displacement, flickering in and out of existence. While the Navy has consistently denied the experiment ever took place, the sheer volume of witness testimony and the continued classification of related documents fuel the belief that something catastrophic and reality warping occurred, an early and deadly stumble into the mechanics of temporal displacement. This anecdotal evidence is not confined to a single disputed event. There are countless reports from ordinary people who experience what are known as time slips, brief, unplanned, and utterly jarring moments where they seem to step into another era. The most famous of these often center around historic locations like the Palace of Versailles in France, where otherwise rational tourists have reported suddenly finding themselves in the court of Marie Antoinette, seeing people in period dress and hearing conversations in Old French, only for the vision to vanish as quickly as it appeared. These are not hazy daydreams. They are often described with startling sensory details, specific smells, sounds, and textures that feel more real than the present moment. While skeptics dismiss them as waking dreams or psychological glitches, the consistency of these reports across different cultures and eras suggests they might be glimpses through a temporary crack in the wall of time, moments where the past bleeds into the present without warning. The theoretical framework for such events doesn't require a fantastical machine. It comes from the highest levels of physics, Einstein's general relativity mathematically allows for the existence of closed time-like curves, paths through the contorted fabric of space-time that loop back on themselves, essentially creating a natural time machine. These could form around rotating massive objects like black holes or, as we discussed earlier, cosmic strings. On a quantum level, the phenomenon of particle entanglement, where two linked particles instantly affect each other regardless of distance, hints at a reality where cause and effect are not strictly linear. Some interpretations suggest this spooky action at a distance could be a form of communication that operates outside of our conventional flow of time, perhaps even backwards. These aren't loopholes in physics, they are features of a universe that is not nearly as rigidly chronological as our perception leads us to believe. This leads to the most profound and paranoid implication of all. If time travel is possible, even in a limited or uncontrollable way, then it is almost certainly being done. Not by civilians in public labs, but by shadowy entities with the resources to harness these natural phenomena or reverse engineer the technology. The concept of chrononauts, time travelers, walking among us shifts from science fiction to a terrifying plausibility. Could certain inexplicable historical events, sudden leaps in technology, or even the rise and fall of specific leaders be the result of external manipulation from a future timeline? The very notion forces us to question the authenticity of our entire historical record. What if history isn't a fixed series of events, but a fluid narrative that has been edited and rewritten countless times, with each alteration creating a new branch of reality that only the time travelers themselves are aware of? We, the general populace, would be none the wiser, living in a present that is the product of countless unseen revisions, a stable reality carefully curated by unseen editors from the future. The reason this truth remains the most closely guarded secret is obvious. The weaponization of time would be the ultimate power. Imagine a conflict where one side could erase the other's history, prevent their own mistakes, or assassinate a key innovator in their infancy. The potential for paradox and catastrophic unraveling of reality itself would be unimaginable. Any group that gained even a minimal capability for temporal influence would have an overwhelming incentive to hide that power completely, to suppress all research in the public sector, and to discredit anyone who came close to the truth. They wouldn't just be protecting a technology, they would be protecting the stability of the timeline itself, making the conscious decision that humanity is not ready to hold the power to rewrite its own past. Our linear experience of time, then, may be the greatest illusion of all, not a fundamental law of the universe, but a carefully enforced quarantine for our own protection. Now let's turn our gaze inward to a theory that places us not just in a universe, but within the event horizon of an unimaginably vast cosmic entity. What if the Big Bang wasn't the beginning of everything, but simply the violent birth of a new reality within the belly of a beast? This is the breathtaking proposition that our entire cosmos, with its hundreds of billions of galaxies, exists inside a black hole belonging to a parent universe. It's an idea that sounds like the pinnacle of science fiction, yet it emerges directly from the mathematics of general relativity and offers startlingly elegant solutions to some of cosmology's greatest puzzles. Consider the unsettling similarities between the two most mysterious objects in physics, the black hole and the infant universe. Both are described by Einstein's equations as singularities, points of infinite density where the laws of physics as we know them simply break down. We are told the universe began from such a singularity, a state that defies all logic. But what if that initial state wasn't a unique event but a common occurrence? In this model, the Big Bang is the moment a massive star collapsed into a black hole in a higher dimensional parent universe. The incredible compression of matter and energy during this collapse doesn't just form a singularity. It triggers the birth of an entirely new spacetime continuum with its own laws of physics, hidden safely behind the event horizon of the parent black hole. We aren't the descendants of a cosmic explosion, we are the inhabitants of a cosmic womb. This framework provides a stunningly simple explanation for the ongoing expansion of the universe, a phenomenon we currently attribute to the mysterious force of dark energy. What we perceive as galaxies flying apart from each other could actually be the continued growth of the black hole that contains us. The space-time within a black hole is not static, it is expanding rapidly, and we are riding that expansion from the inside. The event horizon of our parent black hole would be the ultimate boundary of our observable universe, the point beyond which we cannot see because the gravitational pull is too great for even light to escape outward. The cosmic microwave background radiation, the afterglow of the Big Bang, might not be the echo of a beginning, but the signature of the energy released during our universe's violent creation within the outer black hole. The theory even offers a potential solution to the troubling information paradox of black holes. One of the biggest problems in physics is what happens to the information about an object that falls into a black hole. Quantum mechanics says information cannot be destroyed, but black holes seem to erase it. If our universe is inside a black hole, the information isn't lost, it is translated. It becomes the initial conditions, the fundamental constants and laws that govern our new reality. The information that formed a star in the parent universe becomes the DNA of an entire cosmos within its descendant black hole. This creates a fascinating possibility of a Matryoshka doll reality, an infinite regression of universes within black holes within universes. So why is this elegant and powerful theory relegated to the fringes of cosmology, discussed in hushed tones rather than headline news? The resistance is once again a defense of the standard paradigm. The Big Bang model, for all its problems, is the established orthodoxy. It is the foundation upon which decades of research, countless academic careers, and billions of dollars in funding are built. To suggest that the Big Bang was merely a local event within a much larger and older multiverse is to pull the rug out from under this entire intellectual empire. It makes our entire cosmic history provincial, just one page in an infinite book. For physicists who have spent their lives mapping the details of our universe's inflation and evolution, the idea that it's all happening inside a larger structure is existentially threatening to their life's work. Furthermore, the theory is criticized for being nearly impossible to test. How could we ever gather evidence for a parent universe that exists beyond our absolute cosmological horizon? This perceived untestability allows mainstream science to dismiss it as mere metaphysics, interesting philosophy but not real physics. But this dismissal is arguably premature. Certain subtle signatures in the cosmic microwave background, specific patterns of polarization or temperature fluctuations, could potentially carry the imprint of the chaotic birth from the parent black hole. The search for such signatures, however, receives little funding or attention because it challenges the preferred narrative. Accepting that we live in a black hole would force a humility so profound that it would redefine our place in the cosmos not just spatially but hierarchically. We are not the one and only universe, we are one of countless offspring in an eternal cycle of cosmic birth and death, a thought so magnificent and humbling that the current gatekeepers of cosmology seem determined to keep it locked away. Yet the very particles that threaten to scramble our genetic code might also be the key to unlocking the deepest capacities of the human mind. For millennia, mystical traditions have spoken of awakening, of sudden flashes of insight and expanded perception. What if this isn't merely a metaphor, but a biological and neurological response to an environmental trigger, a flood of high-energy cosmic radiation? This provocative idea suggests that the same force capable of causing destructive mutations could also act as a catalyst, jolting our consciousness into higher states of awareness and unlocking latent psychic abilities that have long been considered the stuff of fantasy. History is littered with strange correlations that support this theory. Consider the surge of artistic, philosophical, and scientific genius during the Renaissance. This explosion of human creativity coincided with the beginning of a grand solar minimum, a period of unusually low solar activity. When the sun is quiet, its protective heliosphere weakens, allowing a greater influx of galactic cosmic rays to bathe our planet. Could this increased radiation exposure have subtly altered brain function on a wide scale, leading to the incredible leaps in intuition and imagination that defined the era? Fast forward to the 20th century, and we find another curious anomaly. In the years following the detonation of the first atomic bombs and the subsequent above-ground nuclear tests, which flooded the environment with low-level radiation, there was a documented, statistically significant rise in reports of paranormal phenomena and unidentified flying object sightings. It's as if a global, low-dose radiation event acted as a trigger, temporarily heightening perception and making the unseen more visible to a larger segment of the population. The mechanism for this might be found not in mysticism but in neurobiology. Our brains operate on a delicate balance of electrical impulses and chemical signals. Cosmic rays composed of high-energy protons and atomic nuclei can pass through the skull and interact directly with neural tissue. This interaction could potentially ionize molecules within neurons, disrupting standard neural pathways and forging new, unexpected connections. It might stimulate the pineal gland, long considered a potential seat of higher awareness, or alter the production of neurotransmitters like dimethyltryptamine, which is theorized to play a role in dream states and mystical experiences. In essence, this particle bombardment could be physically rewiring our brains for a brief moment, dissolving the standard filters of perception and allowing us to access information and dimensions of reality that are normally closed to us. Modern, albeit fringe, scientific studies have attempted to probe this connection. Research into the effects of geomagnetic storms and solar flares has shown tentative links to changes in human consciousness, with some studies noting increases in intuitive accuracy or dream vividity during periods of high solar activity. Volunteers in controlled settings have demonstrated a slight but measurable increase in their ability to correctly guess hidden images or influence random number generators during these cosmic events. While the results are often subtle and difficult to replicate consistently, the pattern is intriguing enough to suggest there is a signal hidden within the noise, a faint whisper of a connection between the cosmos outside and the cosmos within our own minds. So why is this line of inquiry not a major focus of neuroscience or psychology? The answer lies in the rigid dogma of materialism that currently dominates institutional science. The prevailing worldview insists that consciousness is an epiphenomenon, a mere byproduct of the brain's chemical processes. To suggest that external, non-terrestrial forces can directly influence and enhance consciousness is to challenge this foundational belief. It opens the door to concepts that sound uncomfortably close to paranormal activity or spiritualism, ideas that are anathema to a discipline that has spent centuries distancing itself from what it considers superstition. Grant proposals for such research are routinely rejected not on their scientific merit, but on their philosophical implications, dismissed out of hand as pseudoscience before a single experiment can be properly designed. This suppression is also a matter of control. The idea that ordinary people could, under the right cosmic conditions, tap into enhanced intuitive or psychic abilities is deeply threatening to existing power structures. Our entire society is built upon systems of expertise and hierarchy. What happens if anyone, given the right celestial alignment, can access knowledge or perception that was once the domain of specialized institutions? It democratizes awareness in a way that is inherently destabilizing. Furthermore, if these abilities were proven to be real and trainable, it would create a new frontier of human potential that could not be easily monetized or controlled by corporations or governments. It is far safer for the establishment to relegate these experiences to the realm of coincidence, mental illness, or fraud, effectively burying a truth that could empower individuals in ways we are only beginning to imagine. The radiation that falls from the stars may hold the key to our next evolutionary step, but we are being told to close our minds and look away. What if the biggest explosion we can imagine wasn't an explosion at all, but the universe's very first breath exhaling into existence from a gateway we can barely conceive of? The Big Bang Theory tells us everything began from an infinitely dense point, a singularity. But this idea has always contained a troubling paradox. How can something come from nothing, and how can a point of infinite density just suddenly decide to expand? A radical alternative, one that solves these paradoxes with breathtaking elegance, suggests our cosmos didn't erupt from nothingness, but was birthed from a white hole, the theoretical opposite of a black hole, a region of space-time where matter and energy can only pour out, not in. Imagine a black hole in a parent universe, a region where gravity is so strong that nothing, not even light, can escape. But what happens to all that matter and energy that gets sucked in? The mathematics of general relativity allows for a fascinating possibility. It doesn't just vanish. It could be ejected into an entirely separate space-time continuum, a new universe with its own laws of physics. In this model, the Big Bang wasn't a mysterious explosion in a void. It was the moment this cosmic umbilical cord connected, the instant our universe began receiving the energetic outflow from a white hole, a gateway from another reality. This white hole hypothesis elegantly sidesteps the most vexing problems of the standard Big Bang model. For instance, the horizon problem asks how regions of the universe on opposite sides of the sky have the exact same temperature and properties when, according to the standard timeline, there hasn't been enough time for them to ever communicate and equalize. Inflation theory was invented to solve this, a period of impossibly fast expansion just after the bang. But inflation itself is an unproven add-on with its own set of complications. The white hole model offers a simpler, more elegant solution. If our entire universe was birthed from a single, coherent source, the throat of a white hole, then everything we see was initially in contact. It all came from the same place, already thermally equilibrated before being stretched and expanded by the continued outflow. The perfect uniformity of the cosmic microwave background isn't a mystery. It's the signature of our shared origin point, the fingerprint of the white hole that spawned us. So why is this elegant and compelling idea not the leading theory in cosmology today? The resistance is not based on the strength of the science, but on a deep, almost philosophical commitment to a narrative that centers our universe as a unique, isolated event. The Big Bang model, for all its flaws, tells a story with a definitive beginning. It fits a comfortable linear narrative that aligns, perhaps unconsciously, with religious creation myths, a single moment of Genesis. The white hole theory, by contrast, suggests our universe is just one link in an infinite chain, a child universe born from a parent. This is a profound cosmological demotion. It means we are not special. We are one of countless cosmic offspring in an eternal cycle of birth and rebirth. This idea is existentially unsettling for many scientists who have built their careers on the standard model, as it makes our entire field of study feel provincial, just one small chapter in a much grander, multiversal story. There's also a powerful institutional inertia at play. The Big Bang is the reigning paradigm. Billions of dollars in research funding, thousands of academic careers, and the entire structure of modern cosmological education are built upon its framework. To shift to a white hole origin story would be to declare a significant portion of that work potentially obsolete or, at best, relevant only to our local cosmic neighborhood. The peer review system, designed to ensure quality, often acts as a system of peer enforcement, protecting the status quo from radical challenges. Papers proposing serious white hole cosmology are often dismissed out of hand or relegated to obscure journals, not because the math is wrong, but because the idea is too disruptive to the established order. The gatekeepers of cosmology have made a calculated, if unspoken, decision. It is preferable to defend a flawed but familiar model than to embrace a revolutionary one that humbles our place in the cosmic order and forces a complete rewrite of every textbook ever printed. The truth of our white hole origin remains in the shadows, not because it is implausible, but because it is too revolutionary for the current rulers of the scientific establishment to accept. And while we often imagine intelligent signals coming from distant exoplanets, some of the most compelling and unexplained transmissions might be originating right here in our own solar system, from planets we thought we already understood. For decades, our most powerful radio telescopes have been picking up intense, complex, and highly structured emissions from the gas giants Saturn and Jupiter. These aren't the random hisses and pops of natural plasma noise. They carry the distinct hallmarks of organized information, patterns that echo the kind of modulated signals we ourselves use for communication. The most famous of these is the Saturn electrostatic discharge, a powerful radio signal detected by the Voyager probes that pulses with a stunning regularity, a rhythmic beat that stands out starkly against the background noise of space. Similarly, Jupiter broadcasts immense continent-sized radio storms from its polar regions, some of which are so strong they can be detected by amateur astronomers on Earth with relatively simple equipment. These emissions are not merely energetic, they exhibit a degree of fine structure and modulation that natural processes, like lightning or interactions with solar wind, struggle to fully explain. It's the difference between hearing the random crackle of static and hearing a distinct, repeating sequence of notes. One is chaos, the other implies a mind. The official explanations from space agencies consistently frame these phenomena within the comfortable confines of known physics. Jupiter's decametric radio emissions, for instance, are attributed to a complex electron-cyclotron maser instability, a process where electrons spiral along magnetic field lines and generate radio waves. While this is a valid physical mechanism, it often feels like a convenient catch-all, a label used to dismiss the more peculiar aspects of the signals, such as their unexpected timing, their precise frequencies, or their bizarre harmonic structures. The same pattern occurs with Saturn's emissions, which are often written off as intense but natural lightning storms in its atmosphere. This is the standard scientific playbook. When faced with an anomaly, find the closest natural analog, apply the label, and declare the case closed. The problem is that this process often ignores the data that doesn't fit the chosen narrative, smoothing over the rough edges of the mystery to present a tidier but less accurate picture. So why this persistent effort to explain away what could be the most monumental discovery in human history? The motivation is a potent cocktail of institutional self-preservation and a deep-seated fear of paradigm shifts. The entire field of planetary science, with its textbooks, its tenured professors, and its multi-billion-dollar missions, is built upon a foundation of understanding these worlds as complex but ultimately natural systems. To suddenly entertain the possibility that some of the phenomena we're observing are artificial would force an immediate and humbling admission that our fundamental understanding of our closest planetary neighbors is not just incomplete but fundamentally wrong. It would invalidate decades of research and force a complete reassessment of every mission's findings. Furthermore, admitting that such signals could be artificial would immediately and irrevocably force the ET question into the mainstream. It's one thing to search for distant signals from light years away. It's another entirely to have to acknowledge that something potentially intelligent might be operating on Jupiter or Saturn right now in our own backyard. The social, religious, and political implications of that realization are so vast and destabilizing that it is deemed far safer to keep the discussion locked within the narrow confines of natural plasma physics. The truth is filtered not because the evidence is weak, but because the consequences of accepting it are too great for the current scientific and political establishment to bear, leaving us to wonder if the giant planets in our sky are not just worlds but silent, watching sentinels. But what if the most accessible portal to these infinite worlds isn't a colossal machine or a cosmic string, but a state we all enter every single night? The act of dreaming, often dismissed as random neural firing, might be our brain's natural technology for navigating the multiverse. This idea emerges from the cutting edge of quantum biology, which suggests that structures within our brains, like microtubules in our neurons, could be operating on a quantum level. At this infinitesimal scale, the rules of reality are fluid, and a principle called quantum superposition allows particles to exist in multiple states simultaneously. If our consciousness is somehow rooted in or influenced by these quantum processes, then when we dream, the loosening of our waking cognitive controls might allow our awareness to briefly synchronize with or even drift into other versions of reality in the vast multiversal tapestry. Think about the sheer visceral reality of a powerful dream. You're not just watching a movie, you are there. You feel the chill of the wind, the grip of fear, the texture of a wall under your fingertips. These experiences are often more emotionally resonant and sensorially rich than a daydream or a memory. Now consider the bizarre, non-linear logic that governs these worlds. You can be in your childhood home one moment and a fantastical city the next, with the transition feeling perfectly natural in the moment. This fluidity of time, space, and identity mirrors the kind of reality shifts we would expect when moving between parallel dimensions where different choices led to different outcomes. Those jarring moments of dream déjà vu or the intense archetypal encounters with dream figures might not be mere symbolism from your subconscious, but genuine glimpses of other lives being lived by other versions of you. The neurological process of dreaming provides a fascinating potential mechanism for this interdimensional travel. During the rapid eye movement stage of sleep, our brain's activity is a paradox. It's incredibly active, almost as if we're fully awake, yet our body is paralyzed by the brainstem to prevent us from acting out our dreams. This state of hyperactive, internally focused consciousness, decoupled from physical sensory input, could be the perfect condition for our awareness to tune into other vibrational frequencies of reality. It's as if our brain is a radio receiver. When we're awake, it's tuned to one very clear, strong station, consensus reality. But when we dream, the dial turns and we begin to pick up faint signals, crosstalk, and broadcasts from stations on adjacent bands, the realities that are almost but not quite identical to our own. So why does mainstream neuroscience vehemently reject this possibility, preferring to stick with the safer, if less satisfying, theory that dreams are just the brain's way of sorting memories or processing emotions? The resistance is not based on a lack of intriguing evidence, but on a deep philosophical commitment to materialism. The current paradigm insists that consciousness is solely a product of the brain, a ghost in the machine that cannot exist independently of it. To suggest that consciousness can project beyond the skull and into other realities is to breach that materialist wall, venturing into territory that has more in common with ancient shamanic traditions or spiritual practices than with hard science. For a field desperate to be taken seriously as a hard science, this is an unacceptable heresy. It opens the door to concepts of a soul, of astral projection, and of an afterlife, ideas that the scientific establishment has spent centuries trying to debunk in its quest to explain the universe through purely physical mechanisms. This dismissal is a profound failure of curiosity. By defining consciousness as nothing more than brain chemistry, neuroscience places a ceiling on human potential. It reduces the breathtaking, multidimensional experience of a lucid dream where individuals report a sense of hyperreality and often profound spiritual insight to a simple chemical glitch. It ignores the countless consistent reports across cultures and history of prophetic dreams, shared dreams, and out-of-body experiences during sleep, simply because they don't fit the model. The truth is being suppressed not by a malicious conspiracy, but by a kind of intellectual cowardice, a fear that exploring this connection would delegitimize the entire field, sending it back into the dark ages of superstition. In doing so, they are not protecting science, they are protecting a dogma, and in the process, they may be blinding us to the most incredible journey our minds are already taking each and every night, a journey to the edges of reality and beyond. And this brings us to the final and perhaps most foundational truth of all, a deception that underpins the entire edifice of modern cosmology. We are told with absolute certainty that our universe is approximately 13.8 billion years old, a figure calculated through a series of seemingly robust methods. But what if this precise number is the greatest scientific misdirection of all, a carefully guarded fiction designed to prop up a crumbling standard model? A growing body of evidence suggests the universe might be either infinitely ancient, existing in a perpetual cycle of renewal, or startlingly younger than we've been led to believe, and the scientific establishment's refusal to seriously debate this reveals a deep-seated fear of a paradigm shift that would render their life's work obsolete. The primary pillar supporting the 13.8 billion year age is the measurement of the cosmic microwave background radiation, the faint afterglow of the Big Bang. By mapping its tiny temperature fluctuations, scientists have calculated the universe's expansion rate and extrapolated backwards to a beginning. This method, however, rests on a mountain of assumptions about the nature of dark energy, dark matter, and the physics of the primordial universe, a physics we admit we do not fully understand. It's like trying to determine the exact age of a tree by measuring the width of a single ring, while being blind to the fact that the tree's growth rate might have changed dramatically over its lifetime due to unknown factors. Any error in our assumptions about these mysterious components, which make up over 95% of the universe, introduces a colossal error in our age calculation. Even more damning are the celestial objects that appear older than the universe itself. Take the Methuselah star, or HD 140283, located within our own galaxy. Using well-established stellar evolutionary models, astronomers calculated its age to be around 14.5 billion years, a clear 700 million years older than the calculated age of the universe itself. The official response wasn't to question the age of the universe, but to tweak the error bars on the star's age estimate, pushing it just barely into the acceptable range. This is a classic example of paradigm protection. When the evidence contradicts the theory, the evidence is massaged to fit rather than the theory being abandoned. It's a process that prioritizes the preservation of a consensus over a genuine pursuit of the truth. Then there is the problem of fully formed galaxies discovered at the very edge of our observable universe. The James Webb Space Telescope has been sending back images of massive, mature galaxies that appear to have formed barely 300 million years after the hypothesized Big Bang. According to the Standard Model, there simply hasn't been enough time for gravity to pull together such vast structures from the primordial soup. It's like finding a skyscraper in the middle of a landscape that, according to all maps, should be an empty, untouched wilderness. The existence of these cosmic teenagers in the universe's infancy suggests our timeline is profoundly wrong. Either the universe is much older than we think, giving these galaxies ample time to form, or our understanding of galactic evolution is fundamentally flawed. The suppression of this debate is not accidental. It is a systemic feature of modern academia. The Big Bang model, with its definitive beginning, is the foundation upon which thousands of careers, billions of dollars in research funding, and the entire cosmological narrative is built. To suggest that the universe might be infinitely old, existing in an endless cycle of expansion and contraction as proposed by conformal cyclic cosmology, or even that it is significantly younger, is to threaten that entire intellectual empire. A young universe would throw the constants of physics into question, while an infinitely old one would remove the need for a creation event altogether. a concept that makes many scientists deeply uncomfortable as it ventures into philosophical territory they are unwilling to tread. Consequently, research proposals that challenge the orthodox age are routinely denied funding, and papers presenting contradictory evidence are often rejected by major journals whose peer reviewers are themselves invested in the standard model. The age of the universe is not a settled fact discovered through impartial science. It is a dogma protected by gatekeepers who have decided that a stable, if incorrect, narrative is preferable to a truth that would force a humbling and complete rewrite of every textbook on the shelf. So after this journey through 30 cosmic truths, what are we left with? We started with the possibility that our entire reality is a sophisticated simulation, a rendered experience where the laws of physics might be nothing more than cleverly written code. We then saw how the very expansion of the universe could be fueled by our own collective consciousness, a radical connection between mind and cosmos that mainstream science actively suppresses. We examined the overwhelming evidence for advanced technology in our ancient past, from detailed descriptions of flying machines to artifacts like the Baghdad battery, all systematically ignored to protect a linear timeline of human progress. We redefined black holes not as ultimate endpoints, but as potential gateways or wormholes to other universes, and confronted the bizarre anomalies of our own moon that suggest it might be an artificial construct. We unraveled the illusion of time itself, discovering that the past, present, and future may all exist simultaneously in a vast block universe, with our linear experience merely a useful interface for our consciousness. We explored the terrifying and transformative power of cosmic radiation, a force that could be both a driver of evolution and a catalyst for unlocking latent psychic abilities, a truth deemed too dangerous for public consumption. We considered the Sun as a potential portal, with structured objects larger than Earth seen entering and exiting its corona, their evidence often censored from public satellite feeds. We ventured into the many worlds interpretation, where every choice spawns a new universe, and grappled with the alarming weakening of Earth's magnetic field, a looming planetary event with catastrophic implications that is being deliberately downplayed. We looked at the credible, whistleblower-backed evidence for UFOs and the government cover-ups that have kept their reality hidden, all to protect humanity's fragile sense of superiority. We saw how consciousness itself might be the primary force that collapses quantum probability into reality, a truth suppressed because it empowers the individual and threatens systems of control. We felt the pull of the Great Attractor, a gravitational anomaly so massive it's dragging our entire galaxy toward it, with its true nature likely classified. We uncovered the potential for zero-point energy, a limitless power source suppressed to maintain global energy scarcity and economic control. We challenged the Big Bang itself, exploring cyclic cosmological models that suggest our universe has no true beginning or end. We reconceived dark matter not as an exotic particle, but as the gravitational shadow of matter from a parallel dimension. We pondered a living universe whose large-scale structure mirrors the human brain, hinting at a cosmic consciousness. We questioned the very nature of gravity, exploring theories that it's not a fundamental force but an emergent illusion arising from deeper quantum processes. We even considered cosmic strings as natural time machines and the Oort cloud as the ultimate hiding place for ancient alien artifacts. We delved into the Fermi paradox not as a genuine mystery, but as a lie masking a galactic quarantine or secret treaties. We investigated the possibility that the speed of light is not a constant, but a variable that has changed over time, a truth that would unravel modern physics. We faced the mind-bending theory of quantum immortality, where your consciousness might never truly die. We heard the strange, structured radio signals emanating from Jupiter and Saturn that defy natural explanation. We proposed dreaming as a natural form of interdimensional travel and the universe's birth from a white hole in a parent cosmos. and we ended by questioning the very age of the universe, a number that may be the biggest dogma of all, upheld to protect a scientific empire built on a shaky foundation. Taken together, these truths do not paint a picture of a cold, random, and accidental universe. They reveal a cosmos that is breathtakingly strange, potentially alive, and intelligently structured. They suggest that our history is not our own, that our physics is incomplete, and that our place in the cosmos is far more significant and interconnected than we have been led to believe. This is not about wild conspiracy. It is about a consistent pattern of anomaly, suppression, and paradigm protection that spans disciplines from archaeology and astronomy to physics and history. The common thread is control over knowledge, over technology, and over the human spirit's perception of its own potential. By keeping us in a state of managed ignorance, certain institutions maintain their authority and a system of artificial scarcity. But the evidence is now bubbling up everywhere, from declassified documents to the data from our own telescopes, and it is becoming impossible to ignore. This is your invitation to become a conscious participant in this great unveiling. Question the official narratives, read the alternative science, look at the evidence for yourself, and don't be afraid to entertain ideas that challenge the status quo. The greatest adventures in understanding lie just beyond the borders of what we're told is possible. I want to hear which of these truths resonated most with you, or if you have your own evidence for a hidden cosmos. Share your thoughts and experiences in the comments below. Let's get a real conversation started. If you're ready to go further down the rabbit hole, make sure you subscribe and hit that notification bell, because next time we're pulling back the curtain on suppressed technologies. We'll be exploring everything from free energy devices and anti-gravity propulsion to healing machines that could have revolutionized medicine, all locked away in black projects. You won't want to miss it. Until then, keep looking up and never stop questioning.